Hello there, and welcome to Quiet Science, where the vastness of the universe turns into a quiet companion, and the most daunting questions become something you can simply rest beside. Tonight, we're drifting toward one of the strangest places ever imagined. A place where the rules we know break apart, where gravity becomes so overwhelming that even light can't find a way out, and where time itself begins to behave in ways that feel almost impossible. It's called the singularity, the point at which the universe, as we understand it, seems to run out of instructions. But before we dive into that, I wonder where you're listening from. Maybe you're in a dark room with nothing but the soft glow of your screen. Or perhaps you're lying in bed while the world outside is quiet and still. And if you are, I'd like to ask you a small question. Do you ever think about how far away the edge of everything really is? Because tonight we'll take our time wandering toward it gently, one idea at a time. The solar system feels familiar. Planets and moons, the sun at the center. But when you ask what's above it or below it, the answer takes us into places that few of us stop to imagine. Most of us think of the solar system as a kind of picture in a textbook. A flat row of planets circling in neat rings, all arranged like beads on a string. But that image hides as much as it shows. Above that flat disk and below it are worlds tilted strangely out of place, icy bodies scattered into shadows, and eventually, the quiet halo of comets stretching in all directions. So tonight, we'll begin in that simple flat plane, where the planets circle in patient orbits. And then slowly, we'll tilt our gaze upward and downward, layer by layer, until we reach the edge of the sun's power, and finally, the dark ocean of the galaxy. If you find this soothing, or if this quiet trip through the cosmos helps you slow down, I'd be grateful if you gave this a like or even subscribed. It helps keep this calm corner alive for anyone else who might need a soft escape from a noise. Now let's begin. Imagine yourself drifting upward, away from Earth. The blue oceans shrink, the white clouds thin into threads. Soon the planet is a glowing ball beneath you, the moon circling silently at its side. Keep rising, and Earth and the moon slip together into a single point of light. The sun still glows ahead, huge and steady, and around it the orbits of the other planets draw invisible paths like ripples in water. This, the ecliptic, is the solar system's floor, and for a moment we stand on nothing but that floor. It is flat, delicate, almost like glass. But now tilt your view upward. What is above this plane? The question feels strange, almost as if you've stood in a two-dimensional painting and suddenly realized there might be a way to step out of it. Above the solar system, there is space, yes, but also the first signs that not everything clings to this flat order. Pluto, for example, rides high above the ecliptic at one point in its orbit, then dives below it, tracing a tilted loop that ignores the neat pattern of its planetary siblings. Other worlds, with names most of us never hear, Haumea, Makemake, Eris, slip upward and downward too. It's here, above and below the solar system, that the story truly begins. When we look at pictures of the solar system in books or online, what we usually see is a kind of map, the sun in the middle and rings stretching outward like the grooves on a record. Mercury close in, Venus glowing, Earth carrying oceans, Mars glowing red, then the wide belts of the gas giants, and beyond them, the ice giants. The image is neat, clear, almost like a classroom diagram. But what we don't always stop to notice is that this map is flat. The planets aren't scattered in all directions. They are aligned almost perfectly, as though someone pressed them into the thin skin of an invisible sheet. This invisible sheet is what astronomers call the ecliptic plane. It is the quiet stage on which the planets carry out their endless orbits. Why is the solar system flat? To answer that, we need to drift backward in time, billions of years, long before Earth had oceans or even a surface. In the beginning, our solar system was nothing but a cloud of gas and dust. It stretched across space like a ghostly mist, hydrogen and helium from ancient stars mixed with heavier elements born in explosions of supernovae. Over time, this cloud began to collapse, pulled inward by gravity. As it collapsed, it didn't fall evenly from every side. Some parts fell inward faster than others, And because the cloud already carried the slightest rotation, that rotation grew stronger as it tightened. Just as a skater spins faster by pulling in their arms, the collapsing cloud spun faster as it shrank. With that spin came flattening, until the swirling cloud of gas stretched into a disk. Out of this disk, the planets formed. This is why, today, billions of years later, most of the planets are confined to the same thin plane. They are children of the disk, still circling in the flat sheet that gave them birth. When we say above or below the solar system, what we usually mean is above or below this plane. Picture it for a moment. A vast invisible floor stretching outward from the sun, not solid, but defined by the paths of the planets. Mercury zipping quickly, its year just 88 days. Venus slow and veiled, Earth carrying us along. Mars dusty and quiet. Jupiter swollen with storms. Saturn crowned with rings. Uranus tilted sideways. Neptune far away and slow. All circling this flat sheet, each orbit a nearly perfect circle. Almost, but not entirely, because the planets tilt ever so slightly. Earth's orbit is tilted by just about 2 degrees compared to the average plane. Mercury leans about 7 degrees. Pluto, though called a dwarf planet, is tilted by 17 degrees. These tilts mean that if you could draw the solar system in 3 dimensions, some orbits would rise a little above the sheet, others dip slightly below. Yet for the most part, the planets remain close to the ecliptic, never straying far. From Earth, this flatness is something we can see. Look up at the night sky and notice how the moon, the sun, and the planets all seem to trace similar paths. They follow a band called the zodiac, an echo of the ecliptic plane. Ancient astronomers noticed this long before they knew what a solar system was. To them, the planets were wandering stars that never left that band. Today, we know the reason. The band is simply the view of the flat plane from which we are looking outward. But let's pause here, because this detail is worth resting in. Imagine you are floating far above the solar system, looking down. The sun glows in the center, and the planets form a flat, thin disk around it. Now slowly tilt your perspective so that you are level with the plane. From this angle, the solar system seems like a razor-thin slice of light, almost too narrow to see. And above it, a silent, endless blackness. Below it, the same. The flatness makes the emptiness above and below feel even deeper, as though the solar system itself is just a delicate ribbon stretched across a vast void. This flatness also shapes the way we think about above and below, because in reality, there is no universal up or down in space. The terms are relative. Astronomers define north of the solar system as the direction above the ecliptic where Earth's North Pole points. If you imagine the solar system as a table, then above is the side where Earth's axis points, and below is the opposite. But this is just convention, a choice we made, not a law of the universe. In truth, if you turned the whole solar system upside down, it would still work exactly the same way. So why does this matter? Because when we ask what exists above and below the solar system, we're not just asking about directions. We're asking about the shape of our cosmic neighborhood. We're asking what happens when you step off the flat floor of the planets into the emptiness that surrounds it. Before we move on, let's linger for a moment longer inside this plane. Think of the forces that keep it flat. Gravity pulls the planets inward toward the sun, while momentum keeps them moving forward. These two affects balance, creating stable orbits that lie close to one another. The reason they don't wander far above or below is that they all formed from the same spinning disk. It is as though they are marbles, still rolling along the grooves of the track that shaped them. Of course, not everything obeys the rules so neatly. Even here, inside the main system, there are exceptions. Asteroids, for example. The main asteroid belt between Mars and Jupiter holds millions of rocky fragments, leftovers from the early days of planet formation. Most of them lie close to the ecliptic, but some tilt upward or downward, their orbits slightly inclined. And then there are comets, icy wanderers that swing in from far beyond, often at steep angles. When they pass through the solar system, they remind us that above and below the plane are not empty, but part of the same shared stage. This chapter, the plane of the planets, is our foundation. It is the thin sheet from which everything else rises. To understand what lies above and below, we first need to understand this flatness itself, its history, its causes, and its quiet persistence. And as we move forward, we will begin to step off this plane, one layer at a time. First to the tilted wanderers, then the belts of ice, then the great halo of comets, until finally we find ourselves adrift in the galaxy itself. But for now, let your mind rest in the image of the solar system as a flat, thin disk, a glowing sun in the center, the planets circling like clockwork, a delicate floor stretched across space, balancing light and darkness, order and mystery. Above it, silence. Below it, silence. And within it, us, tiny passengers on a world that is itself no more than a grain in a flat river of worlds. When we think of the solar system, it is tempting to picture it as a well-behaved family, the planets circling neatly in their lanes, the sun glowing steadily at the center, and everything arranged on that invisible sheet we call the ecliptic. But families always have their outliers, the ones who wander, the ones who refuse to sit quietly where they are placed. In the solar system, those outliers are the tilted wanderers, the worlds and objects whose orbits climb high above the ecliptic and then dip down below, like children sneaking out of line. Pluto is the most famous of these. Once considered the 9th planet, it now wears the quieter title of dwarf planet. But perhaps what makes Pluto truly fascinating is its path. Unlike Earth or Mars, whose orbits hug the ecliptic closely, Pluto's orbit is tilted by about 17 degrees. Imagine the solar system's flat disk as a table. Most of the planets roll smoothly around the edge of that table. Pluto, on the other hand, is a marble that doesn't stay on the table's surface. It lifts up and arcs above it, then dives below, carving a tilted ellipse through the darkness. And Pluto is not alone. Other dwarf planets follow strange, inclined paths. Haumea, with its stretched egg-shaped body, spins rapidly while circling at a tilt. Make, smaller and distant, also drifts away from the plane. Eris, discovered in 2005, lies even farther out, on an orbit so tilted and elongated that for part of its journey it soars far above the solar system's plane. These tilted orbits remind us that while the solar system was born in a flat disk, gravity does not always keep things tidy. Over billions of years, encounters between objects, nudges from giant planets, and the restless mathematics of orbital dynamics slowly pulled some worlds off the sheet. A close pass with Neptune might push an icy body upward, sending it into a steeper orbit. A chain of gravitational interactions might lift another object downward, away from the plane. One by one, these wanderers slipped away, creating a solar system that is not as flat as it first seems. The story does not end with dwarf planets. Asteroids, too, can be tilted wanderers. Most of the millions of asteroids in the main belt between Mars and Jupiter orbit close to the ecliptic, but some lean at steep angles. There are asteroids whose orbits rise 20, 30, even 40 degrees above the plane. A rare few, called retrograde asteroids, orbit almost completely upside down, circling the sun in the opposite direction from the planets. From our perspective, they plunge above and below the ecliptic with every loop. Comets are perhaps the most dramatic tilted wanderers of all. Unlike the quiet circles of the planets, comets sweep in on long, stretched ellipses. They come from the distant reservoirs of the solar system, diving inward toward the sun, glowing with tails of gas and dust as they warm, then vanishing back into the dark. Many of these paths are tilted steeply, some nearly vertical to the ecliptic. From the perspective of someone floating above the solar system, comets look like messengers, cutting across the orderly planetary plane from all directions, weaving threads through the fabric of the disk. These tilted wanderers are not mistakes or outliers in a negative sense. Instead, they are storytellers. They tell us about the restless history of the solar system. When Pluto arcs above the ecliptic, it whispers of ancient gravitational games with Neptune. When an asteroid leans 40 degrees off the plane, it speaks of collisions and near misses that bend its path. When a comet dives in from the Oort Cloud at a right angle, it carries a message from the farthest reaches, a reminder that the solar system is not only flat, but also spherical, filled with orbits from every angle. If you imagine the solar system from the side, it looks like a thin pancake. But watch more closely, and you'll notice that the edges are not perfectly clean. Small sparks drift above and below, like fireflies escaping the rim of a lantern. Each of those sparks is a tilted wanderer, a piece of ice or rock tracing its own path. It is easy to think of these wanderers as lonely, but in truth, they form a population of their own. Astronomers classify them by their inclinations, grouping them into families and resonances. Some are trapped in orbital dances with the giants, especially Neptune, which shepherds many distant objects into locked rhythms. Others are scattered chaotically, flung outward by past encounters, never to settle into a quiet groove. Together, they form what might be called the solar system's rough edges, the places where order gives way to variety, where the flat sheet of the ecliptic begins to warp into something more textured. Above and below the solar system, these wanderers remind us of perspective. To an observer far away, looking down from above, they would appear as faint, glittering specks, hovering just beyond the main disk. They expand the solar system into 3 dimensions. They take the neatness of the plane and give it thickness, depth, and a touch of unpredictability. Let's pause with one of them for a moment. Picture Eris, far beyond Pluto, orbiting the Sun on a tilted ellipse. It is a lonely, frozen world, so distant that sunlight there is a pale echo, like a whisper of warmth. Eris spends much of its long orbit far above the ecliptic, circling in slow silence. If you were to stand on its icy surface and look toward the Sun, you would see the disk of the solar system tilted below you, a faint, glowing sheet stretching across the distance. The planets would all be huddled together on that sheet, while you, from your tilted path, would be looking down at them from above. From Eris, the solar system itself looks flat, fragile, and small. This shift in perspective is powerful. We often imagine ourselves at the center of things, Earth as the stage where the cosmic play unfolds. But from the tilted wanderers, we are simply part of a flat band, one layer in a larger 3-dimensional structure. Above us are worlds that barely cross our thoughts, icy giants of silence. Below us are others, tracing slow arcs through the dark. And together, they remind us that the solar system is not a single plane, but a layered space with texture and variation. In time, we will drift farther outward to the Kuiper Belt, where tilted wanderers become the norm rather than the exception. But before we do, let's sit with the thought that even here, within the reach of the known planets, the solar system is not quite as flat as the diagrams show. It is already stretching upward and downward, its edges feathered by tilted paths, its family joined by wanderers who refuse to stay on the table surface. They are not accidents. They are part of the design, hints of the larger structure waiting to be revealed. Above and below the solar system, the tilted wanderers are the first voices calling us outward. Out beyond the familiar planets, past Neptune's long, cold orbit, there lies a region that seems at once both empty and impossibly full. It is not a place of blazing suns or swirling galaxies, but a quiet band of icy remnants, drifting silently at the very edges of the solar system. This is the Kuiper Belt, a realm of frozen fragments, wandering worlds, and mysteries older than Earth itself. To imagine the Kuiper Belt is to picture a twilight zone of space, where the light of our sun grows faint and fragile, reaching across billions of kilometers until it can do little more than cast a pale shimmer across the cold surfaces of drifting objects. The Kuiper Belt is a frontier, not the kind of frontier where explorers build fires and maps, but a frontier of time, of memory, of what was left behind when the solar system first came into being. It is not simply a belt of debris. It is a graveyard of beginnings, a place where unfinished worlds, never granted the chance to grow, still linger like forgotten sketches in a cosmic notebook. If you were to drift out there slowly, carried on a ship that whispered through the dark rather than roared, you would notice the gradual thinning of the planetary neighborhood. Jupiter, Saturn, Uranus, and Neptune, each a massive guardian of the outer regions, would fade into the background as you moved past Neptune's cold, blue light. Then, somewhere around 30 astronomical units from the Sun, 30 times farther than Earth, you would begin to cross into the threshold of the Kuiper Belt. Unlike the rocky asteroid belt that sits between Mars and Jupiter, the Kuiper Belt is not densely packed with objects colliding and breaking apart. It is spread across a vast canvas, from roughly $30 to $55 away from the Sun, an expanse so large that even light itself takes hours to travel across it. Objects out here are spaced apart by unimaginable distances. Yet compared to the emptiness that lies even farther out, the Kuiper Belt is still a place of crowded stories. It is here that Pluto resides, the once proud ninth planet now reclassified as a dwarf world. Pluto is not alone in this demotion. Eris, Haumea, and Makemake all join it as dwarf planets, members of a hidden population of icy worlds that orbit far from the warmth of the Sun. These worlds are strange. Some are covered in frozen methane, others reflect the Sun's dim glow like mirrors of ice. Their orbits are tilted and stretched, crossing paths in ways that seem almost chaotic compared to the orderly circling of the inner planets. And yet, for all their irregularity, they are survivors. They have endured for billions of years, unchanged in many ways since the first days of the solar system. The Kuiper Belt is often described as a disk, but this picture can be misleading. It is not a flat and tidy ring, but a collection of different orbital families. Some Kuiper Belt objects travel in neat, almost circular orbits, aligned with the planets. Others wander in eccentric, elongated paths, looping far outward before returning inward again. Still others are locked in resonance with Neptune, meaning their movements are linked in a gravitational dance with that distant giant. The most famous of these resonant objects is Pluto, whose orbit resonates with Neptune's in such a way that they never collide, even though their paths cross. Neptune, in many ways, acts as the gatekeeper of the Kuiper Belt, shaping its structure with its steady pull, sculpting the fates of objects that stray too close. But what makes the Kuiper Belt so compelling is not just its architecture. It is what it represents. This is a region filled with remnants of the early solar system, icy planetesimals that never merged into larger planets. Back when the solar system was young, a disk of dust and gas swirled around the newborn sun. In the inner regions, heat and radiation allowed rocky worlds like Earth and Mars to take shape. In the outer regions, beyond the frost line, ices could survive, and larger giants like Jupiter and Saturn formed. But farther still, at the edge, where the sun's warmth was weakest, growth slowed. There was not enough material, not enough energy, for these small icy objects to become full-sized planets. And so they remained small, locked in time, like fossils of creation. For astronomers, studying the Kuiper Belt is like opening a time capsule sealed for 4.6 billion years. Each frozen surface holds clues to the chemistry of the primordial solar system. Water ice, methane ice, ammonia, and carbon-rich compounds lie preserved, barely altered by the faint sunlight. Where Earth's surface has been reshaped by tectonics and weather, the Kuiper Belt surfaces are ancient, unchanging, scarred only by the slow rain of impacts. To land there, to touch a rock from that realm, would be to touch something as close as possible to the original building blocks from which everything else emerged. In 2015, the New Horizons spacecraft offered us our first close glimpse of one of these frozen worlds. After a decade-long journey, it flew past Pluto, revealing a landscape far richer and more dynamic than anyone had dared to imagine. Instead of a dead, frozen husk, Pluto displayed mountains of water ice, vast nitrogen plains that seemed to flow like glaciers, and a thin, hazy atmosphere that shimmered in the dim sunlight. It was a world alive with slow processes, reshaped not by warmth, but by the delicate balance of frost and sublimation. Later, New Horizons continued on to visit another Kuiper Belt object, Arrokoth, a strange, red-hued body shaped like two spheres gently fused together. Its form spoke of a quiet union in the early solar system, a moment when two small bodies came together without shattering. It was a reminder that the Kuiper Belt is not only a place of isolation, but also of connection. Yet the Kuiper Belt remains a place of mystery. Astronomers suspect that it holds far more objects than we have yet seen. Our telescopes can only reach so far, and the dimness of these icy bodies makes them difficult to find. Some estimates suggest that there may be hundreds of thousands of Kuiper Belt objects larger than 100 kilometers in diameter. Most remain hidden, their light too faint to catch from Earth. And beyond the known edge of the Kuiper Belt lies something even stranger, the scattered disk, a region of icy bodies with wildly eccentric orbits, some tilted at steep angles to the rest of the solar system. These scattered objects hint at violent encounters long ago, times when giant planets migrated outward, flinging small bodies into eccentric paths, leaving behind scars in the structure of the outer solar system. The Kuiper Belt also feeds one of the most spectacular phenomena we can see from Earth: comets. Many of the short-period comets, those that swing around the Sun every few decades or centuries, are believed to originate in the Kuiper Belt. These icy bodies, once nudged inward by gravitational interactions, fall toward the inner solar system, where the Sun's warmth awakens them. Their ices sublimate, forming tails of dust and vapor that stretch across the sky. Each comet that passes overhead is not just a spectacle, but a messenger from the Kuiper Belt, a fragment of that distant region visiting us briefly before retreating once more into the dark. The Kuiper Belt also whispers of something more, something still unseen. For years, astronomers have noticed oddities in the orbits of certain distant objects, patterns that suggest they are being tugged by something massive far beyond the Kuiper Belt. This has led to the hypothesis of Planet 9, a giant, unseen world lurking in the far reaches of the solar system. If it exists, it could be many times more massive than Earth, orbiting hundreds of astronomical units away. Its gravitational influence could explain the strange clustering of orbits among distant Kuiper Belt objects. But so far, no telescope has found it. The Kuiper Belt, then, may not be the end, but simply the threshold to something larger, a hint of hidden architecture stretching even farther outward. To think of the Kuiper Belt is to think of distance in a way that feels almost unreal. At Pluto's distance, the Sun is just a bright star, its warmth so faint that surface temperatures hover around minus 220 degrees Celsius. A day there is filled with the faint light of the Sun and the cold sparkle of distant stars. The silence would be complete, broken only by the occasional collision of small bodies, events that happen on timescales of millions of years. And yet, despite the cold and the silence, there is a strange comfort in imagining it. The Kuiper Belt is not hostile so much as it is indifferent. It drifts on, timeless, its icy bodies carrying the secrets of creation, waiting patiently for us to learn how to listen. Perhaps that is why the Kuiper Belt calls to us, not because it is filled with life or heat or energy, but because it is filled with memory. It is the universe's way of holding on to its early drafts, the first attempts at building worlds. In a way, it reminds us of ourselves, unfinished, imperfect, shaped by forces we cannot always see. And like us, it drifts through time, carrying stories from the beginning, waiting for those who are quiet enough, patient enough to hear them. The Kuiper Belt is not the edge of everything. Beyond it lies the Oort Cloud, an even greater realm of icy bodies spread across a sphere that may extend halfway to the nearest stars. But the Kuiper Belt is the beginning of the edge. It is the first whisper that the solar system does not end where the planets stop, but continues outward, fading gently into the dark. To understand the Kuiper Belt is to understand that the solar system is not a neat family of 8 planets circling a star, but a sprawling, complex system with hidden members, forgotten regions, and mysteries still unfolding. And so, as we let our minds drift across this frozen band, it helps to think of it not as a distant, unreachable place, but as part of the same story we inhabit. The atoms in our bodies, the water we drink, the ground beneath our feet, all were shaped by the same primordial disk that gave rise to the Kuiper Belt. When we study those icy remnants, we are not looking at something foreign. We are looking at our own beginnings, preserved at the edge of sunlight. The planets we know feel almost like neighbors, as though they are strung along a great invisible thread of gravity, circling the sun in their own steady rhythm. Mercury with its blistering heat, Venus cloaked in clouds, Earth with its balance of seas and skies, Mars with its silent deserts, and then the gas giants, Jupiter and Saturn with their mighty bulk, Uranus and Neptune with their cool, bluish glow. Beyond Neptune, though, the familiar order begins to blur. The solar system does not stop where the last planet ends. Instead, something else begins, something quieter, stranger, almost like a dimly lit attic of the cosmos where forgotten things rest. This place is called the Kuiper Belt. Imagine drifting outward past Neptune, watching its pale blue disk shrink behind you. The sun itself dims to little more than a bright star. The planets fall away like fading lanterns. And then slowly, you find yourself entering a region filled with faintly glittering shards, leftovers of the early solar system, objects that never grew large enough to become planets, fragments that circle the sun in darkness. The Kuiper Belt is not empty. It is vast and scattered and full of mysteries. It stretches like a great ring, beginning just beyond Neptune's orbit, about 30 times farther from the sun than Earth, and extending outward for perhaps 50 times that distance. But to understand its true scale, try this. If the Earth's distance from the sun were just one step, the Kuiper Belt would lie 30 to 50 steps away. It is not a wall, not a boundary, but a region, a zone where frozen worlds drift in silence. Some are as small as pebbles, others hundreds of kilometers across, and a few, like Pluto, Eris, and Haumea, are large enough to be called dwarf planets. If you could wander through it, though, you might be surprised. You might expect a field of glittering ice, a dense belt where objects cluster like pearls on a string. But the truth is more subtle. The Kuiper Belt is spacious. Each object, each lonely shard of ice or rock, is separated by immense gulfs of emptiness. To travel from one to the next might take millions of kilometers. The belt is not crowded. It is diffuse, like a whisper that extends across the edge of the solar system. Yet it is filled with meaning, for these bodies are fossils, remnants of a time before planets, survivors of a chaos that once ruled the skies. Long ago, when the solar system was young, the sun was surrounded by a disk of gas and dust. Within this disk, clumps formed and grew, colliding, merging, sometimes shattering apart again. The inner disk, warm and bright, gave birth to rocky planets. Farther out, in the cooler regions, the gas giants formed, their gravity pulling in vast envelopes of hydrogen and helium. But in the farthest reaches, beyond Neptune, growth slowed. The sun's warmth was too faint, collisions too rare, and the objects there remained small, never coalescing into full-fledged planets. They stayed as icy fragments, like a population of half-finished worlds. Those fragments are what we now call the Kuiper Belt. To us, from Earth, they are almost invisible. Even the largest ones are tiny points of light, lost among stars. But as telescopes improved, astronomers began to uncover them, one after another, like faint signals from a hidden realm. In 1930, Pluto was the first to be spotted, though at the time it was thought to be a true planet. Decades later, it became clear that Pluto was just one of many. And once astronomers discovered Eris, slightly smaller but more massive than Pluto, it forced a reckoning. The discovery led to Pluto's reclassification as a dwarf planet, and with it came a new understanding. The solar system's architecture was far more complicated than we had imagined. The Kuiper Belt is not uniform. It holds families of objects, divided into groups by their orbits. Some follow nearly circular paths, steady and calm, as if they've been stable since the beginning. Others have eccentric orbits, stretched into ellipses, as though tugged by the gravity of Neptune. Some spin rapidly, perhaps shattered and reshaped by ancient collisions. Others carry strange features. Haumea, for instance, is elongated, almost egg-shaped, with icy fragments orbiting around it, thought to be the remains of a colossal impact. These worlds are small laboratories of history, preserving the fingerprints of cosmic events that happened billions of years ago. Now, imagine standing on one of these worlds. Perhaps Pluto, with its pale, pinkish ice plains stretching to the horizon. Above you, the sun would shine no brighter than a dazzling star. Shadows would be long, and the cold would be unimaginable. Mountains of ice would rise in silence, sculpted not by rivers or wind, but by the slow movements of nitrogen frost. The sky would be nearly black, pierced by distant stars, and somewhere nearby, the faint disk of Neptune might shine like a jewel. To be there would be to witness stillness itself, a kind of cosmic slumber where time feels stretched, where nothing hurries, where the pace of change is measured in millions of years. The Kuiper Belt also guards secrets about the very beginnings of life. Many of its objects contain ices rich in organic compounds, molecules of carbon, hydrogen, nitrogen, and oxygen, the very ingredients that, under the right conditions, can give rise to biology. Some astronomers believe that comets, which come from the Kuiper Belt, may have carried these molecules to the young Earth. Imagine that fragments from the farthest reaches drifting inward, falling into Earth's skies, seeding the surface with the chemistry of life. The Kuiper Belt, in this sense, is not just a relic of the past. It may have been a gift giver, a distant, icy nursery that helped prepare our world for what was to come. And then there are mysteries that push us further still. The orbits of some Kuiper Belt objects are strangely aligned, as though influenced by something massive, something unseen. This has led astronomers to speculate about the existence of a hidden planet, a Planet 9, lurking far beyond Neptune. If it exists, it would be many times larger than Earth, circling the Sun on a path so distant that one revolution could take tens of thousands of years. Its presence is unconfirmed, yet the thought lingers that perhaps the Kuiper Belt is shaped not only by Neptune, but by an undiscovered giant, hiding in the outer dark. The Kuiper Belt is not only an archive, it is a gateway. Beyond it lies the scattered disk, where objects roam on wild, tilted orbits, some extending nearly into interstellar space. Beyond that, perhaps, lies the Oort Cloud, a sphere of icy bodies that marks the edge of the sun's influence. In this way, the Kuiper Belt is like a threshold, a middle ground between the familiar planets and the true deep of the galaxy. To cross it is to leave behind the last echoes of the solar system's order and to approach the borderland where the sun's voice grows faint. For now, though we linger within it, picture the Voyager spacecraft launched in the 1970s, gliding through these spaces. They were not designed to explore the Kuiper Belt, yet they pass its realm, carrying messages from Earth, golden records etched with music, greetings, and the sound of waves. One day, perhaps in some unimaginable future, a Kuiper Belt object may collide with a wandering probe, the ancient and the modern brushing against each other in silence. Or perhaps more likely, the spacecraft will simply drift onward, untouched, passing beyond the belt and into the void. To speak of the Kuiper Belt is to speak of something quiet, a place that does not demand attention but rewards patience. It is a whisper of the early cosmos, a reminder that the solar system did not end with the last planet. It stretches outward, fragile, faint, yet filled with meaning. Each object is a frozen memory, each orbit a sentence in the long, slow poem of the sun. When we dream of space, we often think of distant galaxies, of stars burning billions of light years away. Yet here on the edge of our own system, there is still so much left unseen, so much left unknown. The Kuiper Belt is proof of this, an entire realm that remained invisible to us until just a few decades ago, and which still hides countless secrets in its dark. To wander through it in imagination is to practice patience. It is to let your thoughts stretch into the quiet, to picture icy mountains, frozen plains, scattered fragments circling endlessly, slowly, gently. The Kuiper Belt does not rush. It does not demand. It simply drifts year after year, aeon after aeon, waiting for us to notice, waiting for us to understand. And in that way, it is not unlike the night itself, vast, dark, and calming, inviting us not to hurry, but to breathe and to listen. Far beyond the familiar orbit of Neptune, out past the swirling giants that dominate the outer reaches of our solar system, lies a frontier so quiet, so dim, that it feels less like a neighborhood and more like the threshold of a dream. It is here, in this shadowed expanse, that the Kuiper Belt stretches like a frozen ring around the sun, an invisible halo made not of light, but of silence and ice. If the planets we know are bustling cities, alive with motion and history, then the Kuiper Belt is more like the countryside at night, still and hushed, with the occasional lantern flickering in the darkness. To arrive here, even in imagination, is to travel far from warmth. The sun, once overwhelming and impossible to ignore, has dwindled to a sharp white star. Its glow still commands the orbits of everything here, but it no longer dominates the sky. Shadows become eternal, and heat, so abundant near Earth, becomes a memory. Everything in the Kuiper Belt is old, colder than any winter you could imagine, untouched by warmth for billions of years. And yet, it is here that the solar system hides some of its most delicate treasures. When astronomers first suspected this realm, they thought of it as a kind of attic of the cosmos, a place where forgotten relics from the solar system's childhood might still linger. Bits of matter that never grew into planets. Fragments of frozen water, methane, and ammonia. Remnants too small to carve out their own kingdoms, but too stubborn to vanish entirely. These icy bodies, thousands upon thousands of them, still drift quietly in a ring that begins just beyond Neptune, about 30 times farther from the Sun than Earth, and stretches outward for billions of miles. The Kuiper Belt is not empty. It is not vast nothingness. It is more like a gallery of unfinished stories. Each small, frozen world tells of what might have been, of the solar system that nearly came to be, but didn't. Unlike the great planets with their commanding gravity, the Kuiper Belt holds only fragments. But in fragments, sometimes, lies memory. These are the building blocks of planets that never found the chance to become whole, and because of that, they are ancient, unspoiled, and pure. One of the most famous of these frozen wanderers is Pluto. Once celebrated as the 9th planet, Pluto has since been reclassified as a dwarf planet. But far from being demoted, Pluto has become something even more intriguing, a symbol of the hidden richness of the Kuiper Belt itself. When the New Horizons spacecraft arrived at Pluto in 2015, humanity expected to find a simple ball of frozen rock and ice. Instead, we discovered a world of mountain ranges made of water ice, plains of nitrogen frozen smooth as glass, and an atmosphere that shimmers faintly before escaping into space. Pluto is proof that even here, on the edge of sunlight, worlds are alive with quiet drama. But Pluto is not alone. Other dwarf planets keep it company in this frozen corridor. Eris, Haumea, Makemake, each with strange surfaces and stranger orbits, each carrying secrets about how the solar system was built. Eris is larger than Pluto, locked in a distant path that swings it even farther into the dark. Haumea spins so quickly that it is stretched into the shape of an egg, and it may even have a faint ring of its own. Makemake reflects sunlight in hues of red and white, like a pale jewel lost in the abyss. And beyond them, still undiscovered, are likely hundreds of other small worlds, waiting for the gaze of telescopes yet to come. It is difficult to imagine the Kuiper Belt as it truly is. In pictures, it is often drawn as a dense disk, thick with icy shards and rocky remnants, each one colliding and bouncing like pebbles in a river. But in truth, it is incredibly sparse. The distances between these bodies are vast. If you were standing on Pluto, you would not see neighboring dwarf planets glowing on the horizon. Instead, the sky would be as lonely as ever, with stars pricked against an endless black canvas, and the sun no brighter than a distant lantern. The Kuiper Belt is a realm of solitude, where worlds float in isolation, bound together only by the faint thread of the sun's pull. Yet even in this silence, there is a kind of elegance. The orbits of Kuiper Belt objects weave together like a tapestry, some resonating with Neptune's gravity, others stretching into elongated paths that hint at unseen influences. Astronomers suspect that something even larger may lurk farther out, a hidden giant, sometimes called Planet 9, whose presence is betrayed only by the way these smaller bodies tilt and cluster, as if nudged by a hand we cannot see. Whether or not Planet 9 exists remains a mystery, but the Kuiper Belt whispers of its possibility with every unusual orbit. The Kuiper Belt is also a birthplace of comets. Many of the comets that sweep dramatically through our inner solar system, with their glowing tails and radiant arcs, are travelers from this frozen ring. Most of the time, they drift silently in the cold, unremarkable and unseen. But sometimes, disturbed by the gravity of Neptune or a passing star, they are cast inward, falling toward the sun. There, the heat wakes them, and they begin to shed their icy skins in streams of vapor and dust, becoming the luminous messengers we glimpse from Earth. To watch a comet is to glimpse, for a brief moment, the Kuiper Belt itself. When you think of the Kuiper Belt, imagine a library of ice, each fragment a book that has not been opened in billions of years. To touch one would be to touch the beginning of everything we know. The early solar system was once chaotic, filled with collisions and collisions, as dust and rock clumped together to form planets. But not all material made it to the center stage. Some was flung outward, exiled to the edge of the sun's influence, where it has waited ever since. The Kuiper Belt is that exile, a frozen echo of a time when the solar system was still finding its shape. But there is also beauty in exile. To drift undisturbed for eons is to endure, to carry memory intact when everything else has changed. Earth has shifted through ice ages and warm periods, through extinctions and rebirths. Mars has lost its rivers. Venus has become a furnace. But the icy remnants of the Kuiper Belt remain as they were, silent witnesses to the passage of 4.5 billion years. If the planets are stories written and rewritten, the Kuiper Belt is a diary left untouched on a shelf, waiting for curious hands to open its pages. And so, here we rest, at the edge of Neptune's dominion, gazing outward into this ring of frozen relics. The Kuiper Belt is not loud, not dramatic, not urgent. It is quiet, unhurried, and timeless. To imagine it is to slow your breathing, to let your thoughts drift outward into the dim places where the sun is no longer warm, but still, somehow, present. It is the borderland of our home, the gentle fade between the familiar and the unknown. As we drift farther, we will leave the Kuiper Belt behind. But for now, let us linger here a little longer, in this hushed corridor of forgotten worlds. For it is in places like this, silent, ancient, and cold, that the universe invites us to listen not for answers, but for echoes. Echoes of beginnings. Echoes of the time before planets, before Earth, before we even knew to ask what might exist beyond the sky. Far beyond the planets, past the orbits of Neptune and Pluto, beyond the icy rubble of the Kuiper Belt, there lies a realm so vast, so quiet, and so lightly imagined, that it is more like a dream than a landscape. This place is not something our telescopes have ever truly seen. It exists in the mind's eye, in mathematical hints, in gravitational whispers, and in the way comets visit us like messengers from an invisible frontier. Scientists call it the Oort Cloud. If you imagine the solar system as a house, then the sun is its hearth, the planets are its rooms, and the Kuiper Belt is the garden just beyond the door. The Oort Cloud, by contrast, is the fence line lost in fog, so far away that you can barely make out its edges. And unlike a garden, this fence is not just a boundary. It is an entire spherical shell that may encase our solar system like a fragile glass globe, filled with billions, perhaps trillions of icy fragments, ghostly remnants of creation, still orbiting, still waiting, on timescales beyond comprehension. To understand how strange and distant the Oort Cloud is, it helps to pause for a moment and let scale sink in. From Earth to the Sun is about 93 million miles, or 1 astronomical unit. From the Sun to Neptune, the farthest planet, is about 30 astronomical units. The Kuiper Belt, where Pluto lives, extends from about 30 to 50 astronomical units. And the Oort Cloud? It is thought to begin perhaps 2,000 astronomical units away, and stretch as far as 100,000. That means that between the Kuiper Belt and the first grains of the Oort Cloud lies an expanse of empty space larger than everything we've already crossed combined. It is as if, after walking through an endless field, you come to a cliff, And on the other side lies another world, wrapped around you in every direction. No one has ever seen the Oort Cloud directly. The sun is simply too far, and the icy bodies there are too small, too faint, too quiet. The idea of its existence was born in the mid-20th century, when the Dutch astronomer Jan Oort noticed a puzzle. Comets that fall into the inner solar system seem to come from all directions, not just from the flattened plane of planets and the Kuiper Belt. Their orbits were long, stretching thousands or even millions of years. They looked as though they had been pulled in from a great reservoir far beyond the edge of known space. Oort imagined this reservoir as a sphere of icy objects, a cloud so far away that the sun's gravity barely holds them. They drift there like forgotten debris from the making of the solar system, leftovers that never quite formed into planets, asteroids, or Kuiper Belt worlds. When something, perhaps a passing star, or the tidal forces of the Milky Way itself, nudges one of these icy fragments, it begins a long fall inward. Most take millions of years to reach the warmth of the sun, and when they finally do, we see them blossom into comets. Long tails of ice and dust streaming across the night sky, briefly burning before vanishing again. Comets, then, are not just curiosities. They are letters sent from a library that exists beyond sight. Each time one appears, we are reminded that there is a frontier out there, untouched and silent, filled with the oldest ice the solar system has ever known. The Oort Cloud is like a time capsule, its fragments preserving the chemistry of the nebula from which the sun and planets were born. To look at a comet is, in a way, to look backward through billions of years into a memory of the cosmos itself. But let's return to the experience of this place, because the Oort Cloud is not just a scientific concept. It is also an imaginative landscape, a space where distance becomes so overwhelming that ordinary measures lose their meaning. If you were to set out toward it, beginning at Earth, your first stop might be the Moon, only a few days' journey away. From there, you might continue to Mars, weeks away, and then Jupiter, months. Beyond Neptune, years would pass before you reached Pluto's realm. And still, the Oort Cloud would lie ahead of you, waiting across distances that no spacecraft has yet touched. Voyager 1, humanity's farthest traveler, has been flying outward for nearly half a century. And still it is only in the first breaths of interstellar space, far inside the boundaries of where the Oort Cloud is thought to begin. Imagine standing on one of these Oort Cloud objects, if you could. The sun would be just a faint star, no brighter than the others scattered across the sky. There would be no warmth, no glow, only a pinprick of familiarity in a sky of strangers. The silence would be absolute, the cold so deep it would feel like the universe itself had stopped moving. Around you, there might be nothing but another shard of ice, tumbling slowly, carrying its orbit on a path that takes millions of years to complete. The solar system, which feels so immense from Earth, would now seem tiny, hidden behind light years of blackness. You would feel as though you had stepped outside of home entirely. Scientists believe the Oort Cloud has two parts, an inner cloud shaped more like a disk, and an outer cloud truly spherical, wrapping around in every direction. The outer portion may be so vast that it brushes against the halfway point to other stars. In fact, the Oort Cloud of our solar system may overlap with the imagined Oort Clouds of neighboring systems, creating a kind of cosmic neighborhood of drifting, frozen rubble. Each star carries with it a faint, invisible halo, and between them, the boundaries blur. Somewhere in that blur lies another mystery, the origin of life's ingredients. Many scientists suspect that comets delivered water and organic molecules to Earth in its earliest days, seeding our world with the first sparks of chemistry that would one day blossom into life. If this is true, then the Oort Cloud is not only a time capsule, but also a cradle, one of the hidden vaults from which the story of life may have begun. Each comet that falls inward may be another chance for a planet somewhere, someday, to be sparked alive. And yet, there is a gentleness in thinking of the Oort Cloud. Unlike the violence of black holes or the furnace of stars, this is a place of stillness, of patient orbits stretched over eternity. It is the quiet outskirts of a home, a whispering forest that surrounds the bright clearing of the planets. If the solar system is a fire burning in the dark, then the Oort cloud is the smoke, thin, diffuse, carried out into the night until it mingles with the greater darkness of the galaxy itself. We do not yet know exactly what waits there. No probe has touched it, no telescope has glimpsed it, no direct measurement has ever been made. It remains an idea, a necessary explanation, a dreamlike sphere that solves a puzzle, but also opens new ones. What is its true size? How many objects drift there? How did they all come to be? And might some of them hold secrets not just of the solar system's birth, but of the galaxy's history as well? For now, we wait and we imagine. We trace the arcs of comets back into the darkness and let them guide our minds outward. Each one is like a thread stretched across time and space, pointing toward the unseen frontier where the solar system slowly dissolves into the stars. As we drift farther, leaving even the Kuiper belt behind, the sun shrinks to a pale point of light. Its warmth is faint, its gravity gentle, and yet it still reaches across the void, tugging slowly at objects that might have forgotten its presence entirely. The Oort cloud begins here at the edge of recognition, where distance begins to stretch meaning itself. Each icy fragment is a solitary traveler, drifting in orbits that can take millions, sometimes tens of millions of years, to complete a single loop around the sun. Time itself slows in such places. A year is no longer measured in days, but in cycles that the human mind struggles to imagine. The Oort cloud is shaped not like the familiar plane of planets, but more like a ghostly sphere. Inside, objects drift in all directions. Some fall inward occasionally, nudged by forces subtle and slow, the gravitational pull of a passing star, the cumulative tug of the Milky Way's mass, or tidal effects from the sun's own motion through the galaxy. These disturbances, small as they are, can release a comet from its millennia-long orbit, sending it toward the inner solar system. When it comes, it ignites the imagination of observers on Earth, blazing across the sky as if to remind us of the universe's far reaches, whispering of the vast loneliness from which it came. We imagine the Oort cloud as cold beyond comprehension, far colder than anything we feel on Earth. Its objects are frozen solid, mixtures of water, methane, and ammonia, unaltered for billions of years. If a fragment could speak, it would tell of a time before planets had settled into their current paths, before the Earth had oceans or the Moon had formed, before life had begun. Every icy body carries the memory of creation itself. Each one is a relic, a fragment of a primordial disk that spun around the young sun, fragments that were pushed outward by gravitational chaos and remained there, unchanging, until now. The sheer distances involved are staggering. Some of the Oort cloud's outermost objects may be halfway to the nearest stars, floating in isolation so profound that light from the sun takes weeks to reach them. Their orbits are slow, almost imperceptible to human perception. One could imagine standing on such a fragment, looking outward into the blackness, and feeling as though the universe itself has stretched and paused, leaving only the faint glow of distant stars as witnesses. Yet despite the cold and isolation, there is life of a sort here, not biological, but historical. Comets that visit the inner solar system carry materials that predate the planets. Organic compounds, simple amino acids, and water, trapped in ice for billions of years, may be released as they heat and vaporize near the sun. These comets, brief travelers through the warmth, may have delivered water to the early Earth, perhaps even seeding it with the chemistry necessary for life. The Oort cloud, in this sense, is not just a distant periphery, but a participant in the story of our planet. It is both guardian and messenger, preserving the past while occasionally sending pieces of it forward. Imagine drifting through this sphere in a spacecraft of the imagination. The fragments float silently, distant from one another, glinting faintly as they catch the rare sunlight. There is no noise, no rush, no warmth. Everything moves at a pace dictated by gravity and inertia, unhurried and eternal. Here, we begin to perceive the full scale of the solar system not as planets and moons alone, but as a structure that extends outward in nearly every direction, fading slowly into the star-studded dark of interstellar space. The outer Oort cloud may even touch other stars' domains. Our solar system is not alone in the galaxy. It drifts amidst billions of others. Each star may carry its own halo of frozen objects, its own Oort Cloud-like sphere. And sometimes, very rarely, these spheres might interact. Passing stars, wandering through the galaxy, can tug at these icy fragments, knocking them loose and sending them wandering into another system. In this way, the Oort Cloud is not merely a boundary of the Sun's domain. It is a link, however fragile, to the galaxy itself. We often think of space as a void, but the Oort Cloud demonstrates that even in emptiness, there is presence. Every fragment in its slow orbit is a testament to survival, to persistence against the endless expanse. And because these bodies are so untouched, they provide clues to the processes that shaped our solar system. By studying comets that originate here, scientists can reconstruct the chemical conditions of the early Sun and the primordial disk of gas and dust that birthed the planets. Each icy visitor becomes a story told in molecules, a chronicle of the universe's youth frozen into rock and ice. And yet, despite its vastness and isolation, the Oort Cloud is dynamic. Comets occasionally get nudged inward, either by galactic tides, passing stars, or interactions with one another. They begin their slow centuries-long journey toward the Sun, tracing arcs that bring them into the inner solar system for just a brief moment in cosmic time. For us on Earth, these visitors are ephemeral sparks, bright and fleeting, but for the fragments themselves, it is a monumental journey that takes longer than the entire span of human civilization. Their arrival is a reminder that even the most distant reaches are not entirely detached, that the boundaries of the solar system are not static, but flexible, shaped by forces both near and far. And so the Oort Cloud invites us to think differently about distance, about time, and about the scale of the solar system. It is not a place of drama, of collisions or explosions. It is a place of patience, of quiet, unhurried orbiting. To contemplate it is to contemplate endurance on a cosmic scale, to let the mind drift and slow as we imagine billions of years passing quietly, without hurry, without interference. It is a meditation on the very nature of cosmic time, a gentle reminder that some parts of the universe exist purely in their own rhythm, waiting for someone, perhaps far in the future, to notice. As we drift even farther, the objects of the Oort Cloud become more scattered, more tenuous. The Sun, once a brilliant beacon, is now just a pale glimmer, barely distinguishable from the countless other stars in the black sky. At this distance, the gravitational pull of the Sun is faint, and the icy bodies move in languid, nearly imperceptible orbits, tracing loops that may last millions of years. Time here is not measured by days or years, but by the patient tick of cosmic rhythm. A single orbit may outlast the entire history of human civilization. The Oort Cloud is a sphere rather than a disk, unlike the Kuiper Belt. It surrounds the solar system in all directions, creating a ghostly halo that may extend nearly halfway to the nearest stars. The scale is staggering. Between you and the nearest fragment may lie millions of miles of emptiness. Each object is isolated, drifting quietly, carrying the memory of the solar system's infancy. These icy remnants are among the most pristine materials in existence, untouched by sunlight or heat, preserved for billions of years in the cold, silent outer space. Occasionally, however, some of these fragments are nudged from their distant orbits. The perturbations can come from passing stars, galactic tides, or gravitational interactions with other objects in the Oort Cloud. These subtle disturbances send comets on long journeys inward toward the warmth of the Sun. It may take millions of years for one to traverse the dark emptiness, moving slowly at first, then faster as the Sun's gravity draws it in. And when it finally enters the inner solar system, it ignites spectacularly, creating a tail of vapor and dust that can stretch millions of miles, visible across the night sky. Each comet that arrives is a messenger from the outermost reaches, carrying clues about the early solar system. Scientists study the composition of their ice and dust to understand the conditions under which the planets formed. Within their frozen material may lie organic compounds, the building blocks of life. Some comets may have even delivered water to Earth. helping to fill its oceans billions of years ago. The Oort Cloud then is not simply a distant repository. It is a keeper of secrets, a preserver of the solar system's earliest moments, and perhaps a contributor to the emergence of life itself. As we imagine moving through this realm, the sense of scale becomes almost unfathomable. Between these icy bodies are immense voids, stretching farther than the mind can easily grasp. In this silence, one becomes aware of how small and fleeting our own existence is. The Earth, bright and alive, the planets, the sun, they are but a cluster of activity in a vast expanse of quiet and cold. The Oort Cloud surrounds us like a protective shell, isolating our solar system from the galaxy beyond, while also acting as a bridge to interstellar space. The outer Oort Cloud may even overlap with the hypothetical halos of nearby stars. Every star in the galaxy may carry its own sphere of icy remnants, and the edges of these spheres might occasionally interact. A passing star could disturb fragments in the outer Oort Cloud, sending them hurtling inward or even transferring them to another system. In this way, the Oort Cloud is not just a part of our solar system. It is a point of connection to the galaxy itself. It reminds us that the sun is not isolated, but part of a vast, moving network of stars, all carrying their own invisible halos of frozen relics. Thinking about the Oort Cloud also brings a sense of philosophical reflection. Here, at the edge of the sun's influence, the boundary between order and chaos becomes subtle. Gravity still holds the objects in orbit, but so lightly that outside influences can easily disrupt them. It is a place of balance, suspended between stability and motion. The icy bodies drift slowly, tracing their paths in silence, each one a testament to endurance, to the survival of matter over billions of years. If you could stand on one of these distant fragments, the experience would be surreal. The sun would be a faint star, almost indistinguishable from the others. The sky would be pitch black, sprinkled with distant galaxies and stars that have traveled millions of light years to reach your eyes. You would feel the weight of silence and the passage of time stretching out in every direction. In that quiet, you might contemplate the fragility and resilience of worlds, of systems, of life itself. And yet, there is comfort in this vastness. The Oort Cloud, despite its remoteness, represents continuity. It is the memory of the solar system's formation, preserved in ice and silence. It is a reminder that even in the most distant, coldest places, there is order, rhythm, and connection. Each comet that eventually travels inward is a bridge between the past and the present, between the hidden frontier and the living planets closer to the sun. In the imagination, we drift among these icy bodies, watching them spin slowly, orbiting a sun so far away that its warmth barely touches them. We sense the patience of time here, the quiet persistence of matter, the elegance of gravity shaping motion over billions of years. And slowly, almost imperceptibly, we begin to understand that the solar system is far larger than the planets alone. Its edge does not end with Neptune or Pluto or even the Kuiper Belt. Its edge extends into this ghostly halo, this sphere of ice and memory, this Oort Cloud, where the history of the cosmos is quietly preserved. Eventually, as our journey continues, the Oort Cloud itself gives way to the infinite, dark expanse of interstellar space. The sun's gravity weakens, and the tiny icy fragments are no longer bound as closely, drifting under the influence of the galaxy itself. Here at the boundary of the solar system, one glimpses the greater context of our existence. The Milky Way, with its billions of stars, each with their own potential halos of frozen debris. The Oort Cloud, vast and silent, is the bridge from our solar system to the rest of the galaxy, a subtle reminder that our world is part of a larger, interconnected universe. And so, as we leave the Oort Cloud behind in our imagination, we carry with us a new understanding. The solar system is not just planets orbiting a star. It is a vast, layered structure, with distant, icy halos preserving the memory of creation, occasionally sending comets to remind us of what lies beyond. It is a place of stillness, endurance, and quiet wonder. It is the edge of the sun's influence and the beginning of interstellar space, a place to contemplate the vastness of time, the immensity of distance, and the patient beauty of the cosmos. In this quiet, we find a kind of solace. The Oort Cloud is not threatening, not violent, not urgent. It simply exists in the darkness, preserving the past and connecting the solar system to the galaxy beyond. And in that gentle presence, we are reminded that the universe is larger than we imagine, filled with mysteries that stretch far beyond our sight, waiting patiently to be discovered, understood, or simply imagined. The Oort Cloud, vast and silent, has receded behind us. Its icy fragments and whispered comets dissolve into the darkness as we drift outward, leaving the comforting tug of the sun's gravity behind. Ahead lies a realm even more mysterious, a place where our solar neighborhood dissolves into the emptiness of interstellar space. It is a frontier not marked by planets, moons, or even comets, but by the sheer expanse of distance and the faint glimmer of stars scattered across the black. Imagine leaving the warmth of the sun behind entirely. Its glow is now a distant pinprick, no more noticeable than any other star on the horizon. The sense of scale begins to warp. Distances that once seemed enormous, like the gap between Earth and Neptune, or even between the Sun and the Oort Cloud, now feel almost insignificant. Here, the void stretches outward, endless and unmeasurable, punctuated only by the occasional distant sun, each carrying its own invisible sphere of planets, debris, and memories of formation. Interstellar space is not empty in the absolute sense, but it is emptiness of a type we rarely experience. Particles of gas and dust float in near-perfect silence, each separated by kilometers of nothing. Cosmic rays stream endlessly, invisible messengers of distant phenomena. Occasionally, a photon from a star trillions of miles away drifts past, as if curious, as if testing the quiet. And yet, within this void, there is structure. Gravity continues to exert its gentle influence, shaping the paths of unseen objects, weaving the web of galactic dynamics, and reminding us that even here, nothing is truly without order. The first real encounter beyond our solar system is with the interstellar medium, a diffuse sea of gas and dust that fills the space between stars. Its density is almost laughably thin, less than a single atom per cubic centimeter. But it is real, a tangible presence that marks the boundary between the familiar and the unknown. It is in this medium that Voyager 1 now drifts, humanity's first emissary into the great beyond, carrying the voices and images of our civilization across unimaginable distances. In its quiet passage, we are reminded that we have begun to step into the realm beyond our solar family, where the rules of proximity and intimacy give way to vastness and solitude. Here, the stars themselves feel different. They are no longer companions clustered in a solar dance, but distant lights in a vast theater, scattered and isolated. Each one has its own planetary system, its own halo of asteroids and comets, its own unseen structures that mirror the architecture of our solar system in ways we are only beginning to understand. And some, perhaps, have Oort clouds of their own, sending icy messengers across interstellar space. Occasionally, these messengers might even wander into our sun's domain, bridging the divide between worlds in the quietest of journeys. One cannot help but think about the vastness of time here. Objects in interstellar space move slowly on cosmic scales, often taking millions of years to traverse distances that, to us, are incomprehensible. A photon of light from a nearby star may take years to reach a passing probe, and a drifting comet might cross the gulf between stars in a journey longer than the span of human history. Time in this region is no longer measured by days or years, but by the silent patience of the cosmos itself. And yet, within this vast emptiness, there is potential. Interstellar space is the cradle of possibilities, a region where stars are born from clouds of gas, where planets may form around distant suns, and where the ingredients for life, organic molecules, water, and complex chemicals, drift across the void, carried by the gentle currents of cosmic winds. It is a realm both inert and fertile, silent yet teeming with potential, where the universe holds in suspense the stories yet to be written. As we continue to drift It is easy to imagine ourselves as travelers on a slow voyage, passing through a cosmic ocean. The sun fades behind us, becoming just another star in the distance, while other lights begin to punctuate the black, each a sun with its own family of worlds. Between them lies emptiness, so vast that we can no longer perceive its edges, only sense its immensity. And in this silence, there is a strange comfort. We are small, yes, but we are part of a grander story, connected to the motions of countless stars and the gentle pull of gravity that stretches across the galaxy. The first encounter with interstellar space also brings reflection. Here, the solar system is no longer a clearly defined neighborhood. It is a cluster of memories and orbits, a bubble within a greater expanse. The boundaries of what we once called home dissolve, and we are left with the realization that our sense of scale has been entirely redefined. Planets, moons, comets, and even the Oort Cloud are fragments of a larger, more complex structure, all carried along by the galactic tide. Even in this emptiness, there is motion. Stars drift slowly, galaxies rotate, and unseen objects move along orbits dictated by the invisible threads of gravity. Occasionally, a passing star may disturb the calm, nudging distant comets into new trajectories, reshaping the subtle architecture of the solar system's outskirts. And occasionally, a fragment from another system may enter our sun's domain, a silent traveler connecting one world to another across light years of emptiness. Interstellar space is the ultimate meditation on distance, time, and scale. It invites reflection on our place in the cosmos, encouraging a sense of humility and wonder. Each drifting object, each faint star, each unseen cloud of gas reminds us of the vastness that surrounds us, the patient forces that shape our universe, and the quiet persistence of matter over billions of years. It is a place where imagination and science meet, where the mind can drift gently through space, contemplating mysteries that may never be fully understood. And in this quiet journey, we begin to sense something profound. The universe is both immense and intimate. The stars are far away, yes, but they are part of a tapestry in which we are woven. The Oort Cloud and the Kuiper Belt were merely gateways. Interstellar space is the beginning of understanding the true scale of our existence. Here, in this silence, we feel the patient pulse of the cosmos, and we are invited to slow down, breathe, and let the mind wander across distances that dwarf any human measure, yet remain connected to us through gravity, light, and time itself. As we drift further into interstellar space, the sun fades more completely, a pale glimmer among countless other distant stars. The warmth that once defined our days is now a distant memory, replaced by the vast, cold silence of the void. In this silence, the scale of the universe becomes almost impossible to grasp. Distances are measured not in millions or billions of miles, but in light years, each a stretch so immense that time and motion themselves begin to feel fluid, stretching and compressing under the weight of imagination. Between stars, the space is not empty, but nearly so. Sparse clouds of hydrogen, helium, and trace amounts of other gases float through the darkness, almost imperceptible, yet forming the raw material from which future stars and planets may be born. These interstellar clouds drift slowly, shaped by the gentle currents of the galaxy and the tidal pull of passing stars. Sometimes, over millions of years, gravity gathers them into denser pockets, sparking the beginnings of stellar nurseries. The galaxy itself is alive in these subtle ways, a slow, quiet breathing that unfolds across epochs far beyond human comprehension. And yet, the quiet is deceptive. Though the space seems empty, it is threaded with unseen motion and potential. Rogue planets, cast away from their parent stars, wander alone through the darkness. Each drifts silently, carrying with it the history of a system long abandoned, perhaps with frozen oceans and hidden rocks, isolated from light and warmth for eons. Some may pass near other stars, nudged into new orbits, or perhaps even captured by a solar system in a rare cosmic embrace. Here, in the infinite expanse, every object tells a story, and every trajectory is a whisper of past collisions, births, and migrations. The stars around us form a diffuse neighborhood, each with its own system, halo, and relics. Their distances are measured in light years, far surpassing anything the human mind can easily picture. Between them lies the great emptiness of interstellar space. Yet within this emptiness is subtle structure. Gravity weaves threads connecting stars and their clouds of gas and dust. Invisible interactions stretch across thousands of light years, shaping the slow architecture of the galaxy. And though we cannot see most of these processes, we feel their presence in the motions of comets, the paths of distant stars, and the distribution of interstellar matter. Drifting through this darkness, one becomes aware of time's elasticity. Light from the nearest stars has taken years, decades, or centuries to reach us. A passing interstellar comet may have traveled for millions of years before entering the inner solar system, carrying with it the frozen secrets of another star. In this realm, time is measured not by days or years, but by the patient drift of objects across space. One sense of immediacy disappears, replaced by the slow rhythm of the galaxy itself. Occasionally, we imagine encountering the relics of distant systems, a cloud of ice, a tiny asteroid drifting across the void, or even a faint remnant of a planetary collision. These fragments are rare and far apart, yet they carry clues about the formation and evolution of stars and planets across the Milky Way. Some may even be chemically related to the building blocks of life, drifting silently toward regions where their molecules might one day ignite chemistry on a distant world. In this way, interstellar space is not just emptiness. It is a vast, patient network connecting distant histories, distant suns, and distant possibilities. The passage of stars through the galaxy creates subtle, ongoing changes. Each star's motion gently tugs on neighboring systems, shifting orbits and nudging clouds of gas, dust, and icy bodies. Over millions of years, these interactions can send objects into entirely new paths, sometimes directing them toward other stars, other systems, or even into the inner reaches of familiar systems like our own. The dynamics are slow, almost imperceptible, yet persistent. The galaxy is alive in its own rhythm, a movement so gradual that it feels eternal, continuous, and unhurried. In this quiet, one can imagine the endless dance of stars and planets, of clouds of gas and drifting comets, all moving according to the patient laws of physics. There is no hurry, no urgency, only the steady unfolding of motions that have persisted since the birth of the Milky Way. And within this quiet, we begin to feel the profound scale of existence, that our solar system is only a small, fragile pocket within an almost unimaginably vast sea of stars, planets, and clouds, each with its own story stretching across millions or billions of years. Here, in this interstellar expanse, it becomes easier to appreciate the delicate balance that makes life on Earth possible. The sun's warmth, the precise orbits of planets, the existence of the Kuiper Belt and Oort Cloud, all of these are threads woven into a larger cosmic fabric. Beyond them lies interstellar space, a realm of almost infinite distances and profound stillness, where the faintest forces shape destinies over eons. It is humbling, inspiring, and quietly reassuring to know that the universe operates on such patient scales, offering both mystery and consistency in its silent motion. As we drift through this void, the imagination can stretch outward to consider the nearest stars. Proxima Centauri, barely over 4 light-years away, is the closest sun beyond our own. Its planets, unseen yet inferred, may drift with similar clouds of ice and dust. Beyond it lie hundreds of other stars, each with systems we can barely begin to imagine, carrying their own stories of formation, migration, and potential life. In the silence of interstellar space, these distant suns appear as companions, their warmth and light faint yet tangible across the void. And so we continue to drift, carried by thought and imagination, through the immense calm of the galaxy. The sun, once the center of our attention, is now a star among countless others. Its influence wanes, its gravity barely reaching the far edges of the Oort Cloud we left behind. Interstellar space stretches endlessly, populated by invisible currents, wandering worlds, and faint relics of creation. Here, we begin to grasp the vastness that lies beyond our familiar solar system, a quiet frontier that invites reflection, wonder, and patience. As we drift even farther into interstellar space, the sense of isolation grows, yet so does the sense of connection. The sun, now a distant pinprick, reminds us of home, while the stars around us begin to hint at the vast neighborhoods of the galaxy. Between these distant suns, immense voids stretch outward, nearly empty, yet alive with the faintest traces of gas, dust, and cosmic radiation. These are the highways and byways of the galaxy, pathways along which stars, planets, and the tiniest icy fragments move over millions of years. Occasionally, a faint object drifts across our imagined path, a rogue planet wandering through the darkness, untethered to any star, a lonely traveler carrying its frozen surfaces through the void. It moves slowly, propelled by the initial energy of formation and the subtle gravitational tugs of stars it may never approach closely. Each rogue planet is a reminder that interstellar space is not merely empty. It is a vast realm of potential, of worlds unseen, drifting in silence beyond the reach of sunlight. In addition to rogue planets, interstellar clouds of gas and dust stretch like faint mists, invisible to the naked eye, but forming the raw material from which new stars and planets may one day emerge. These clouds drift, fold, and compress under their own gravity, slowly forming denser pockets over millions of years. In these slow, gentle movements, the galaxy hums with quiet creativity, crafting the next generation of suns and worlds in the most unhurried way imaginable. The nearby stars, like Proxima Centauri and Alpha Centauri A and B, drift silently, each with its own hidden systems. Their planets may host icy bodies, asteroids, and distant clouds similar to our own Oort Cloud. Some of these objects may one day be nudged toward neighboring stars, carrying their chemical stories across light years. In this way, interstellar space becomes a bridge, linking star systems with threads of ice, dust, and molecules, connecting worlds across incomprehensible distances. We begin to notice the scale once more. Even the nearest stars are separated by trillions of miles, distances that dwarf the extent of the solar system itself. A journey that might take months or years to reach Neptune would be insignificant here. Time stretches into millions of years, motion into slow, almost imperceptible arcs, and space into a canvas, so vast it becomes a meditation on patience, endurance, and the quiet persistence of matter. Within this quiet, the galaxy itself takes shape. Stars drift along orbits around the galactic center, tracing paths that take hundreds of millions of years to complete. Clouds of gas spiral and fold, sometimes collapsing to form new suns. The motion is slow, deliberate, and elegant. There is no rush, no urgency, only the persistent rhythm of a galaxy carrying its silent, countless denizens along predetermined paths. In this rhythm, one can sense the gentle heartbeat of the cosmos, steady and unyielding, a cosmic pulse beneath the stillness of interstellar space. And yet, even in this emptiness, there are occasional disturbances. Passing stars can tug at distant objects, nudging comets or rogue planets into new trajectories. Interstellar fragments may wander into systems far from where they were born. These rare events are the quiet dramas of the galaxy, unfolding over millions of years, imperceptible in a single human lifetime, yet monumental in the story of the cosmos. They remind us that the universe is not static. It moves, interacts, and reshapes itself in ways both subtle and profound. As we drift farther, one begins to feel the immensity of our place in the galaxy. Our solar system, once the center of attention, is revealed to be a tiny cluster in a sprawling galaxy of billions of stars. The Oort Cloud, the Kuiper Belt, the planets themselves, all become fragments within a larger structure, each orbiting the galactic center along slow, steady paths. And beyond, in the interstellar medium, the possibilities stretch endlessly. Potential new stars, planets, and life-bearing worlds, drifting patiently in the darkness, waiting for the conditions that may awaken them. The vastness of space is matched by its silence. Here, no wind, no atmosphere, no sound exists, only the faint passage of cosmic rays, the slow movement of particles, and the gentle tug of gravity across unimaginable distances. In this silence, one can contemplate the elegance of the universe, the beauty of its slow motions, and the patient orchestration of forces that have persisted for billions of years. Every drifting fragment, every distant star, every interstellar cloud is a note in a symphony so vast that the human mind can only begin to perceive it. And so, as we continue to drift through interstellar space, a sense of awe and calm settles. The sun is far behind, the Oort Cloud of memory, and the stars stretch endlessly before us, each carrying its own secrets, histories, and frozen fragments. The universe is vast, patient, and profoundly beautiful. Here, in this quiet expanse, we are reminded of our smallness, yes, but also of our connection to the sun, to the stars, to the slow, deliberate rhythm of the galaxy itself. Interstellar space is not just emptiness. It is a space of potential, of history, and of patient motion. It is a meditation on scale, on time, and on the beauty of a universe that unfolds quietly, with precision and patience. And in that quiet, we find a gentle, contemplative space, a place to let our minds wander, to feel the immensity, and to understand that the universe in all its vastness continues to move, breathe, and exist, whether or not anyone is watching. And as we drift on, carried by imagination and thought, we glimpse the edges of what we can understand, the threshold between our solar system and the galaxy beyond. It is here in the quiet that the journey of exploration, imagination, and wonder truly begins. The vast interstellar ocean stretches ahead, filled with unseen worlds, drifting comets, and the silent pulse of stars. And within it, we are small yet present, wandering gently through the infinite night, carried by curiosity, patience, and awe. Beyond the distant stars and the icy outskirts of our solar system lies a realm both vast and subtle, a space so immense that it seems almost impossible to grasp. Here, the sun is just another pinprick of light, dwarfed by the infinity that stretches in every direction. We have left the gravitational influence of our solar neighborhood behind, and now drift in the gentle, almost imperceptible currents of the interstellar medium, a tenuous fabric that fills the space between stars. The interstellar medium is not empty, though it might seem so at first glance. It is composed of thin clouds of gas, mostly hydrogen and helium, with tiny traces of heavier elements. These clouds are spread so thinly that a single cubic centimeter may contain only one atom, yet they stretch for light years, forming a sparse, delicate lattice that weaves the galaxy together. Invisible currents ripple through this medium, guided by gravity, magnetic fields, and the slow push and pull of stars passing nearby. In this vast emptiness, there is motion and structure, subtle but inexorable, shaping the history of the Milky Way over billions of years. We drift gently through these clouds, imagining the delicate particles around us, each moving at its own pace. Some are drifting freely, unbound by any star, while others are caught in the gravitational whispers of distant suns. Tiny dust grains, smaller than a micron, float silently, catching what little starlight reaches them, reflecting faint glimmers like distant fireflies. And yet, despite their small size, these particles are the building blocks of creation, potential seeds for future stars and planets. Within these quiet clouds lies the promise of birth, of worlds yet to form, quietly waiting for the gravity that will one day gather them into clusters and ignite their hidden energy. The interstellar medium is not uniform. Some regions are dense, forming molecular clouds that are cold, dark, and almost impervious to light. These are the cradles of stars, where gravity slowly draws matter together over millions of years. Within these clouds, temperatures hover near absolute zero, and chemical reactions occur at an almost imperceptible pace. Yet, over time, these slow processes can give rise to stars, planetary systems, and perhaps even the ingredients for life. In this way, the interstellar medium is not just emptiness, it is potential, a quiet laboratory of cosmic creation. As we drift, the distances between stars begin to feel immense. Even the nearest suns, such as Proxima Centauri, lie over 4 light-years away, separated from us by trillions of miles of space, dust, and invisible particles. Between these stars, the interstellar medium acts as both a highway and a barrier, shaping the paths of comets, rogue planets, and cosmic rays as they traverse the galaxy. Occasionally, a passing star will disturb the medium, compressing clouds, nudging objects, or even triggering the birth of a new sun. In this slow, patient motion, the galaxy maintains its rhythm, its quiet order stretching across light years. Beyond these clouds, we approach the edge of the Milky Way, a threshold where the familiar spiral arms begin to fade into darkness. Here, the density of stars and clouds decreases, leaving behind a sparse region where interstellar space dominates. The light from distant suns becomes fainter, and the gravitational pull of the galactic core diminishes. In this quiet periphery, the scale of the universe stretches beyond comprehension. A single wandering cloud or a lone star may drift undisturbed for millions of years, carrying with it a history older than any civilization, untouched by the motions closer to the galactic center. The edge of the Milky Way is not a sharp boundary, but a gradual transition, a thinning of matter and light into the vast galactic halo. Stars here are sparse, often old, their compositions enriched by generations of stellar evolution. Between them, the interstellar medium continues to flow, carrying remnants of ancient supernovae, magnetic fields, and cosmic dust. It is a quiet, delicate realm, a space where one begins to feel both the enormity of the galaxy and the profound patience of the universe. Time and distance stretch together here, urging contemplation, reflection, and a slow, deepening awareness of cosmic scale. Drifting through this region, one cannot help but feel both insignificance and connection. The stars seem distant and cold, yet they are part of the same galaxy that nurtures our solar system, connected by invisible threads of gravity and interstellar currents. Each star, each cloud of gas, each particle of dust is a note in a quiet symphony that has played for billions of years, a song too slow for human ears, yet perceptible to the imagination. In this silence, the mind begins to slow, matching the rhythm of the galaxy, letting the vast distances stretch and bend perception gently. The interstellar medium is also a record of history. Within its faint clouds lie the remnants of stars long dead, supernovae that exploded millions of years ago, scattering enriched material across the galaxy. These clouds carry elements essential for life: carbon, oxygen, nitrogen, slowly drifting until they are captured by nascent stars or planetary systems. In this sense, interstellar space is not just a backdrop. It is an archive of creation, a quiet library storing the raw materials and the memory of cosmic events across eons. And so, as we drift, the Milky Way itself begins to unfold. Its spiral arms stretch outward, thin at the edges, blending gradually into the galactic halo. Stars are fewer here, their spacing immense, and yet there is a rhythm, a slow, persistent dance guided by gravity. Occasionally, a faint cluster or globular collection of stars may appear, its light stretching across the void, a reminder that even at the galaxy's edge, structure persists. The interstellar medium continues to flow, carrying potential, history, and the subtle connections that tie this vast galaxy together. In this quiet exploration, one begins to sense the beauty of patience in the cosmos. Stars are born, live, and die over timescales far beyond human perception. Clouds drift and compress, forming new worlds in ways that unfold across millions of years. And we, drifting quietly in imagination, witness this calm procession, feeling the patient scale of creation and the gentle rhythm that has persisted since the galaxy first formed. As we drift farther into the outer reaches of the Milky Way, the sparse stars seem to float like isolated lanterns in a vast, dark ocean. The glow of the galactic center is now almost imperceptible, and the familiar spiral arms of the Milky Way dissolve into a subtle haze of scattered stars and faint interstellar dust. Here, in this quiet periphery, the interstellar medium stretches out like a nearly invisible fabric, so thin that each particle is alone in its journey, yet together they form a delicate cosmic network. This medium carries the whispers of ancient stars. Supernovae long past have left behind streams of enriched gas and dust, their remnants drifting quietly through space. These particles, born in fiery explosions billions of years ago, are now scattered across unimaginable distances, merging imperceptibly with the interstellar clouds around them. In these drifting atoms lie the very elements that would one day form planets, oceans, and perhaps life itself, a quiet testament to the cycles of creation and destruction that shape the galaxy. Occasionally, we imagine encountering a globular cluster in the distance, a dense, spherical assembly of ancient stars, numbering hundreds of thousands, each locked in a slow, graceful orbit around the galaxy. These clusters are relics of the early Milky Way, their stars older than the Sun by billions of years. From afar, they appear as faint, shimmering beads, like a distant constellation magnified, their collective light softened by the vastness of space. To drift among them would be to step into a living fossil of the galaxy, a region where time feels almost suspended, and the past is preserved in the light of enduring suns. Between these clusters, the galaxy thins, and the darkness becomes deeper. The sparse stars are separated by distances so vast that motion seems almost meaningless. Yet, within this stillness, gravity continues its subtle work, guiding stars, clouds, and remnants along slow paths that trace the spiral shape of the Milky Way. Even here, far from the bustling center, the galaxy is alive with motion, patient and deliberate, unfolding across scales so immense that human perception struggles to comprehend them. The galactic halo, stretching above and below the plane of the Milky Way, is filled with faint, ancient stars and diffuse clouds. Many of these stars have peculiar orbits, remnants of smaller galaxies swallowed by the Milky Way in the distant past. Their motions are slow but precise, and their presence offers a window into the galaxy's history, a glimpse of the cosmic collisions that shaped the structure we see today. In this quiet halo, the history of the galaxy is written in light and motion, in ways that take millions of years to fully unfold. Interspersed among these stars and clouds, we can imagine the presence of dark matter, invisible yet profoundly influential. Though unseen, it shapes the motions of stars and galaxies, providing the unseen scaffolding upon which the visible structures cling. Dark matter's quiet gravity stretches across the halo, subtly guiding orbits, bending paths, and maintaining the coherence of the galaxy's vast shape. It is a reminder that not all that matters is visible, and that the universe contains forces and presences beyond what the eye can detect. Drifting through this outer halo, the sense of scale becomes almost overwhelming. The distances between stars, clusters, and clouds dwarf anything in the inner galaxy, and time feels elastic, stretching across millions or even billions of years. A wandering cloud of gas may slowly condense into a dense core over epochs, so long they defy immediate comprehension. A rogue planet may drift alone for millions of years before encountering a star or another planet. In this slow, patient unfolding, the universe demonstrates a rhythm entirely its own, one that encourages observation, reflection, and quiet awe. Here, in this remote galactic periphery, the faint glow of interstellar particles catches the dim light of distant suns. Tiny grains of dust drift, reflecting what little light reaches them, forming a subtle shimmer across the darkness. Cosmic rays, traveling at nearly the speed of light, pass silently through the medium, carrying with them whispers of distant supernovae, energetic processes, and the invisible mechanisms that shape the galaxy. Even in this apparent emptiness, there is activity, slow, invisible, and profoundly intricate. The interstellar medium and the halo also remind us of the connectedness of the galaxy. Every star, every cloud, every particle is part of a vast network, influenced by the gravity of neighboring stars, the motion of the galactic center, and the subtle tides of dark matter. A star that drifts alone here is still subtly connected, its motion intertwined with the distant, unseen structures that form the skeleton of the Milky Way. In this quiet, distant region, The galaxy feels both immense and coherent, a single organism moving slowly through the cosmic night. And so, as we continue to drift, the galaxy gradually fades into a subtle background, the distant stars stretching into a faint, diffuse glow. The interstellar medium, the globular clusters, the dark matter halo, they are all reminders of the immense patience of cosmic processes. Stars are born, live, and die. Clouds condense and disperse. The galaxy rotates and evolves. All unfolds on timescales far beyond human life. Yet the motions are precise, predictable, and quietly magnificent. Here, at the edge of what we can call the Milky Way, we are invited to pause, to breathe in the silence, to let the mind stretch across light years, and to feel the gentle, patient pulse of a galaxy that has persisted for billions of years. The interstellar medium carries the memory of creation. The halo preserves the relics of ancient stars, and the unseen dark matter provides the invisible threads that hold it all together. Together, they form a quiet frontier, a place of reflection, wonder, and almost infinite calm. As we drift even farther from the familiar spiral arms of the Milky Way, the galaxy becomes a faint, hazy disk, a soft smear of light stretching across the darkness. Here, in the outer halo, the density of stars thins even more. Globular clusters appear as distant, faint spheres, their ancient stars locked in graceful orbits, and the interstellar medium is almost imperceptible, a whisper of gas and dust stretching for light years. The edge of the galaxy feels like a threshold, a boundary where the familiar begins to dissolve into the vast unknown beyond. The outskirts of the halo are populated not only by old stars, but also by subtle streams of debris, remnants of dwarf galaxies long absorbed by the Milky Way. These streams drift silently, their stars tracing the paths of cosmic collisions from billions of years ago. Each star carries the memory of another galaxy, a fragment of a larger story woven into the Milky Way's history. In this quiet, distant region, time feels elongated, and one can almost feel the slow rhythm of galactic evolution, stretching across millions and billions of years. Beyond the halo, the galaxy's influence diminishes, and we approach the intergalactic medium, the space that lies between galaxies. Here, the distances become almost unimaginable. Light from even the nearest galaxies takes millions of years to reach us, and the spaces between them are vast and nearly empty. Yet even here, there is subtle structure. Faint clouds of hydrogen drift across the void, shaped by gravity and the remnants of ancient cosmic events. Occasionally, a faint galaxy can be glimpsed in the distance, its stars a scattered shimmer of light against the darkness. In this intergalactic space, the concept of home transforms. The solar system, the Milky Way, and even our local group of galaxies become tiny islands in a vast cosmic ocean. Rogue stars and wandering planets may drift between galaxies, untethered and isolated, carrying with them the histories of systems they left behind. And though they are few and far between, they serve as reminders that the universe is not static. It moves, evolves, and reshapes itself quietly over time. The intergalactic medium is extraordinarily thin, yet it is the stage for the slow processes that shape the cosmos. Hydrogen and helium clouds drift, sometimes colliding or condensing under gravity, forming the seeds of new galaxies over billions of years. Cosmic radiation streams through this void, carrying energy and information across incomprehensible distances. Here, the universe operates on a scale so vast that human perception falters. Yet within it, there is structure, history, and the potential for creation. As we float in this immense silence, the mind begins to adjust to the scale. Distances that once seemed vast within our solar system now appear negligible. Time stretches, and motion slows to a rhythm governed by gravity across millions of light years. Every star, cloud, and galaxy moves according to forces invisible yet precise, following paths that have been set since the universe itself took shape. In this calm, the cosmos feels both immense and patient, offering a sense of order amid what appears, at first glance, to be emptiness. Beyond the halo, and into intergalactic space, we can also glimpse the cosmic web, the large-scale structure of a universe. Galaxies are not scattered randomly, but form filaments, sheets, and voids, like a delicate lattice suspended in the darkness. These structures are vast beyond comprehension, spanning hundreds of millions of light years. Between them lie immense voids, regions nearly devoid of stars and galaxies, yet subtly shaped by gravity and the slow motion of the universe. Here, the scale of space is humbling, and the patient rhythms of cosmic evolution become almost palpable. Floating through this near-nothingness, one can imagine the passage of time on a scale that dwarfs human history. A photon of light might take millions of years to traverse a void, and a wandering galaxy may drift for eons before encountering another. Even the tiniest intergalactic cloud of gas or dust participates in this slow ballet, carried along by the invisible currents of gravity and cosmic expansion. In this quiet, the universe reveals its immense patience and the delicate choreography that governs the motion of countless worlds and systems. And yet, despite the immensity, there is intimacy here. Every star in the halo, every globular cluster, every drifting cloud is part of a larger, interconnected story. The Milky Way itself is connected to its neighbors, the Andromeda Galaxy, the Triangulum Galaxy, and countless dwarfs, each influencing the motion of the others in subtle, almost imperceptible ways. The universe is vast, yes, but it is not random. There is a quiet order, a gentle coherence that stretches across billions of light years and billions of years. As we linger at this distant edge, the Milky Way behind us, we feel the profound scale of the cosmos. The familiar comforts of the solar system are far away, yet the sense of connection persists. Gravity, light, and time weave together a story that encompasses the smallest dust grain and the largest galaxy. In this quiet frontier, we find both awe and calm. We are small, yes, yet intimately part of the unfolding, patient universe. The motions, the distances, and the histories all stretch into a slow, endless rhythm that invites reflection, imagination, and a gentle sense of wonder. And so, as we drift onward, carried by thought and imagination, we sense the universe's quiet pulse. Stars, clouds, and galaxies move with patience and precision. Structures form, evolve, and dissolve across epochs longer than human memory. The interstellar and intergalactic mediums stretch out in all directions, carrying the history and potential of the cosmos. Here, at the edge of our understanding, in the calm between galaxies, we find a vast, silent frontier, a place to let the mind wander, to feel the rhythm of creation, and to rest gently in the immensity of the universe. As we drift beyond the quiet outskirts of the Milky Way, the distant stars begin to take on a new significance. They are no longer mere pinpricks of light scattered across the sky. They are suns in their own right, each surrounded by its own potential family of planets, moons, and clouds of debris. The nearest of these stellar neighbors are relatively close in cosmic terms, yet the distances are vast enough to dwarf anything we experience within our own solar system. The closest star, Proxima Centauri, lies a little over 4 light-years away. Its faint red glow is barely perceptible, yet it carries with it a world of possibilities. Around this star, at least one planet has been confirmed, a small, rocky world lying within the star's habitable zone, where liquid water might exist under the right conditions. In imagination, we can drift closer to this planet, observing its surface, its potential oceans, its thin atmosphere, and the slow rotation that governs its day and night. Though we have not visited, the mind can wander here freely, imagining the gentle pull of its sun, the faint warmth on its surface, and the possibility of life in some simple, quiet form. Beyond Proxima Centauri, Alpha Centauri A and B shine faintly, a binary pair locked in a slow, elegant dance around each other. Around these stars, planets may circle silently, their orbits steady and precise. The dynamics of a binary system create rhythms entirely different from those of a solitary sun, with planets tracing elongated paths and seasonal changes unlike anything on Earth. In the calm of imagination, we can drift among these worlds, observing the slow interplay of light and gravity, feeling the delicate balance that allows these systems to persist for billions of years. Other nearby stars such as Barnard Star, Wolf 359, and Lalande 21185 are dim red dwarfs, faint yet persistent points of light. Each one is a quiet sun, possibly hosting planets hidden in their glow. Around these stars, icy worlds may drift, comets may wander silently, and clouds of gas and dust may form the raw ingredients of future planetary systems. The sheer scale of distance between these neighbors is staggering. Even the closest star systems are separated by trillions of miles. Vast oceans of empty space, carrying only the faintest particles of dust and radiation. Within these nearby systems, time behaves differently. Light from Proxima Centauri, traveling at 186,000 miles per second, still takes over 4 years to reach us. For any object traveling at ordinary speeds, the journey would take tens of thousands of years. In imagination, we can stretch time, observing the slow rotation of planets, the gradual movement of clouds, and the silent motion of comets drifting through the faint interstellar medium. Time feels patient here, expansive and meditative, a rhythm entirely separate from the busy pace of life on Earth. The nearby stars are not isolated. Invisible threads of gravity connect them subtly to the rest of the galaxy. Passing stars can nudge distant objects, slightly altering orbits, sending comets or rogue planets on new paths. Occasionally, over millions of years, these interactions may even lead to rare encounters between stars or their planetary systems. In the quiet, patient unfolding of time, the galaxy maintains a delicate balance, where even the smallest perturbations can ripple across vast distances, shaping the motions of stars and the fates of worlds. Imagine drifting among the planets of these nearby systems. Some may be rocky, with mountains and valleys sculpted over billions of years. Others may be gas giants, enormous and swirling with storms that rage for centuries. Icy moons may orbit silently, their surfaces covered in frozen oceans, while thin atmospheres breathe faintly under the distant light of their suns. Even in imagination, each world carries its own story, shaped by gravity, radiation, and time, a miniature universe unfolding quietly, parallel to our own solar system. Some of these stars may host planets within the habitable zone, regions where conditions are just right for liquid water to exist. Here, life in some form may have taken root, evolving in silence over eons. We can imagine simple organisms drifting in alien oceans, or the slow chemistry of complex molecules forming in icy caves. In the calm of interstellar space, possibilities expand without end. The mind can wander across light years, contemplating worlds we may never visit, yet feeling a profound connection to the rhythms and motions that govern them. And yet, the distances are humbling. Even the nearest system, Proxima Centauri, is so far that human exploration is still a dream. Any spacecraft traveling at current speeds would take tens of thousands of years to reach it. And beyond the nearest stars, the distances only grow, stretching imagination and patience. This vast emptiness between stars is filled with faint cosmic particles, the quiet drift of rogue planets, and the invisible pull of gravity, all combining to form the subtle currents that guide motion across light years. As we drift among these neighboring systems, the imagination can explore without hurry. A comet may slowly swing past a distant planet, its icy tail catching the light of a faint sun. A rogue asteroid may drift silently through the space between stars, carrying with it the history of a system long abandoned. The movements are slow, deliberate, and profoundly gentle, offering a perspective on the vast patience and order of the cosmos. Nearby star systems, though distant, offer a quiet reminder of the scale and variety of the galaxy. Each is a small universe, with its own planets, moons, and potential histories. Some may be fertile, some barren, some frozen, some warm, and yet all move according to the same fundamental laws, tracing their orbits with patience and precision, shaped by gravity and time in ways both subtle and profound. Even from the edge of interstellar imagination, one can sense the connections. Stars drift, clouds of gas stretch across light years, and particles of dust slowly migrate. Every system is linked to the galaxy's gentle rhythm, influenced by its neighbors, the motion of the spiral arms, and the pull of unseen dark matter. In this calm, the mind begins to expand, feeling the scale of space, the slow passage of time, and the quiet beauty of neighboring suns and their hidden worlds. As we drift deeper into the calm of nearby star systems, the scale of space stretches even further. Each sun becomes a gentle beacon, its light diffused over trillions of miles, touching distant worlds with a warmth that is faint but persistent. Some of these stars are solitary, like Proxima Centauri, while others exist in binary or even triple systems, locked in slow, graceful dances around one another. Around them, planets trace their orbits with patient precision, some small and rocky, others massive and gaseous, each a story unfolding quietly in its own rhythm. In these distant systems, the imagination can wander freely, moving from planet to planet, observing the subtle differences in light, gravity, and atmosphere. A rocky planet may host mountains shaped by billions of years of erosion, valleys carved by slow tectonic shifts, or oceans frozen beneath thick sheets of ice. A gas giant may rotate with storms raging for centuries, its clouds swirling in patterns that never repeat. Moons orbit silently, some icy, some volcanic, each contributing to the calm dance of gravity and motion that defines the system. Some planets, particularly those in the habitable zones, invite the mind to linger. Here, the conditions might allow liquid water to persist on the surface, or within subsurface oceans beneath icy shells. In imagination, we can envision simple life forms drifting through alien seas, or chemical reactions unfolding slowly in hidden caves or oceans warmed by tidal forces. The possibilities are quiet, subtle, and infinite, each world a patient experiment in the unfolding of matter and energy over eons. The space between these stars is vast, almost unimaginable. Even the closest neighbors are separated by distances so large that light takes years to traverse them. And yet, despite the emptiness, there is motion. Cosmic dust drifts slowly, shaped by the gravity of distant suns. Rogue planets wander, untethered and free, and interstellar gas flows subtly, carrying the building blocks of future stars and planets. Every movement is slow, deliberate, and interconnected, part of a rhythm that stretches across millions of years and trillions of miles. Within these systems, time is experienced differently. Days, years, and seasons pass according to the size of the star, the speed of planetary rotation, and the tilt of the axis. Some planets may have long years and short days, while others rotate slowly, their surfaces bathed in extended periods of light or shadow. Tidal forces stretch oceans and warm interiors. Volcanic activity reshapes surfaces, and atmospheric currents redistribute heat and energy. In the calm of imagination, one can observe these subtle processes, feeling the patient unfolding of planetary evolution in a way that is both quiet and profound. Occasionally, we imagine encountering the relics of collisions, an asteroid scattered from its original orbit, a comet carrying icy fragments from the outer reaches, or a small moon displaced by gravitational interaction. These objects drift silently, tracing paths influenced by the subtle pull of nearby stars, and sometimes their journeys extend for millions of years before they settle into a new orbit or vanish into the void. Each fragment is a small story, a quiet echo of past events that shaped the system long before we observe it. Some nearby systems may host multiple planets in stable, delicate arrangements, their orbits finely tuned by gravity over billions of years. Others may be more chaotic, with planets following eccentric paths, their climates and conditions shifting dramatically as they circle their suns. The variety is astonishing, and the calm of imagination allows us to explore them all without haste, moving gently from one world to the next, absorbing the silent, patient logic of celestial mechanics. Rogue planets drifting between these stars are particularly fascinating. Untethered from any sun, they carry their own icy surfaces and slow internal heat, wandering the darkness without a fixed orbit. Their paths may bring them near a distant star for brief periods, or they may drift in complete isolation for eons. These lonely travelers are a reminder of the diversity of motion in the galaxy, and of the quiet patience with which the universe unfolds, far beyond the immediacy of human perception. In these nearby star systems, we also begin to feel the influence of interstellar currents. Clouds of gas and dust drift slowly, interacting with stellar winds, magnetic fields, and gravity. Over millions of years, these currents may seed planets with new materials, trigger the formation of new stars, or subtly alter the motion of comets and asteroids. In this gentle flow, the galaxy maintains its coherence, a quiet, patient network connecting systems, histories, and possibilities across unimaginable distances. As we drift among these distant suns, it becomes easier to sense the profound connection between them and our own solar system. Though separated by light years, every star and planet is part of the same galaxy, moving in accordance with the same laws, participating in the same slow, grand symphony of creation and evolution. The motions, the distances, and the histories all weave together, creating a network of calm, deliberate order amidst the vast emptiness of interstellar space. In this quiet exploration, the mind can wander to the potential for life in these systems. Even in our imagination, the possibilities are endless. Oceans teeming with unknown organisms, deserts under alien suns, frozen moons warmed by tidal forces, and chemical reactions unfolding in hidden caves. These worlds exist in patient slow motion, their processes stretching across millions of years, offering a perspective on time, scale, and the quiet persistence of the cosmos that is both humbling and soothing. And so, as we drift onward, carried by imagination and thought, the nearby star systems stretch before us, each a small universe in itself. The planets, moons, comets, and clouds of dust move in quiet, patient motion, guided by gravity and time. Even the empty spaces between stars are alive with subtle currents, connecting systems and shaping futures. Here, at the calm frontier of our imagination, we find both wonder and serenity, a gentle reminder of the vastness, complexity, and quiet beauty of the galaxy we call home. As we drift farther, beyond the immediate neighborhood of Proxima Centauri and Alpha Centauri, the galaxy opens into a calm, sprawling panorama of stars, each one a quiet sun with its own story to tell. Among these stars, some are ancient reds, their surfaces dim and slow burning, while others are hotter blues and whites, radiating with a brief intensity in cosmic terms. Around them, planets move in patient, unhurried orbits, tracing slow arcs that have persisted for millions or even billions of years. Some of these distant neighbors may host entire families of planets. Gas giants with swirling atmospheres dominate the outer regions, their immense gravitational pull shepherding smaller bodies and comets along careful paths. Closer in, rocky worlds spin slowly under the light of their suns, with possible oceans, clouds, and hidden life. The imagination allows us to drift over their surfaces, feeling the warmth of alien suns, the tug of gravity, and the gentle motion of oceans or icy crusts shifting over geological time. Each world is alive in its own slow, subtle way, a patient participant in the calm dance of the galaxy. Exoplanets, worlds beyond our solar system, stretch the imagination further. Some may be tidally locked, with one side baked by constant sunlight and the other plunged in perpetual darkness, creating climates unlike anything on Earth. Others may orbit multiple stars, their days and nights dictated by complex rhythms of light and shadow. Some worlds may host thick atmospheres, shielding their surfaces from radiation, while others are exposed, winds shaping mountains and valleys over eons. Each planet is a unique experiment in the possibilities of matter, energy, and time, quietly unfolding in its orbit, independent yet connected to the gravitational web of its parent star. Rogue planets continue their slow drift between these systems, untethered and solitary. They move silently, sometimes passing near a star, but mostly wandering in isolation. Their surfaces may be frozen, their cores faintly warm, and perhaps somewhere deep within, conditions exist that could allow life in forms we cannot yet imagine. These lonely travelers are a testament to the patience of the universe, a reminder that motion and history continue even in the most desolate reaches of interstellar space. The space between stars, though seemingly empty, is filled with the faintest currents of interstellar gas and dust. These particles drift slowly, shaped by stellar winds, radiation, and gravity. Over millions of years, they may coalesce into clouds dense enough to form new stars or be captured by existing planetary systems. Even the smallest particle is part of the quiet, deliberate motion that permeates the galaxy, carrying with it the history of formation, destruction, and renewal. Some nearby systems are part of larger clusters, loosely bound groups of stars that form together. In these clusters, stars may pass relatively close to one another over millions of years, subtly influencing planetary orbits and the motion of interstellar clouds. These interactions are rare and slow, yet they remind us that the galaxy is not static. It evolves patiently, shaped by the pull of gravity, the motion of matter, and the passage of cosmic time. In this calm journey, the imagination can linger on the possibilities for life. Planets in the habitable zones of their stars might harbor oceans, simple organisms, or even complex ecosystems. Perhaps on a distant world, life has developed entirely differently, shaped by radiation, gravity, and atmospheric chemistry unique to that star system. Even if life exists only in microscopic forms, its presence contributes to the quiet wonder of the cosmos, a subtle reminder of potential amid vast distances and patient motion. The further we drift, the more the connections between stars become apparent. Gravity, the unseen force, subtly links these systems, guiding their paths and maintaining the coherence of the galaxy. Clouds of gas and dust, remnants of ancient stars, drift between systems, sometimes captured by a planet, sometimes shaping the formation of new worlds. Even the faint currents of cosmic radiation carry energy and information across light years, connecting one distant star to another in ways that are almost imperceptible, yet persistent and essential. In the calm of this exploration, the mind begins to absorb the vast scales of both space and time. Light years separate stars, yet gravitational threads connect them. Millennia pass in what feels like an instant, yet the slow accumulation of matter and energy continues its patient work. The galaxy, in its quiet rhythm, demonstrates both precision and patience, unfolding over scales the human perception can barely comprehend. Each nearby star system is a small, delicate experiment in motion and stability, a miniature universe carrying potential, history, and the quiet unfolding of time. As we drift among these stars, a sense of serenity settles in. The vast emptiness, the distant suns, the wandering planets, and the faint interstellar currents all contribute to a profound calm. Time slows, imagination expands, and the quiet patience of the cosmos becomes almost tangible. Each world, whether frozen, molten, or gently spinning in a habitable orbit, is part of a vast, interconnected network of matter and motion, each contributing its subtle rhythm to the symphony of the galaxy. And so, as we linger at the edge of nearby star systems, the imagination can roam freely, observing distant worlds, tracing the arcs of planets, and feeling the gentle tug of gravity that binds them all. The distances are immense, the motion slow, and the scale humbling, yet there is intimacy in understanding that each system is part of the same galaxy, the same universe that nurtured our solar system. Here, in this quiet frontier, the mind can rest, wander, and marvel at the patient, deliberate beauty of nearby suns and their silent worlds. Beyond the nearby stars, the universe stretches into an endless expanse of possibilities. Around countless suns, planets drift in quiet orbits, tracing paths set billions of years ago by the gentle hand of gravity. These exoplanets, worlds beyond our solar system, are as varied as they are numerous. Some are rocky, like Earth, with mountains, oceans, and thin atmospheres. Others are massive gas giants, swirling with storms that rage for centuries. Some are icy and distant, drifting silently at the edges of their systems. Each one is a miniature universe, quietly unfolding its own story in patient motion. Among these countless exoplanets, some lie within the so-called habitable zone of their stars, where conditions might allow liquid water to exist. This zone is delicate and precise, depending on the size and heat of the star, the orbit of the planet, and the properties of its atmosphere. Imagine a world in this perfect region, a planet bathed in gentle sunlight, oceans glimmering under alien skies, and seasons stretching slowly across its surface. Time here moves in quiet cycles, shaping the planet's climate, weather, and perhaps the slow evolution of life in hidden corners. These habitable worlds might be rocky and temperate, with continents and oceans sculpted over billions of years. Mountains could rise like silent sentinels, shaped by tectonic forces that shift imperceptibly over eons. Oceans might stretch endlessly, their surfaces reflecting the faint light of distant suns. Clouds drift lazily across the skies, moving in gentle currents, carrying rain or snow to nourish the land. Even in imagination, one can feel the rhythm of these worlds, the quiet passage of days, nights, and seasons, and the patient unfolding of life and matter. Other habitable worlds may be covered in dense jungles or rolling plains, their ecosystems thriving quietly under suns very different from our own. Perhaps life there has developed forms we cannot even imagine, shaped by gravity, atmosphere, and chemistry unique to that planet. Microbial life may drift in oceans, evolving slowly, while larger organisms, if they exist, follow gentle, deliberate cycles of growth and decay. Each world is its own laboratory of possibility, moving in perfect synchronization with the forces that govern the galaxy. Some exoplanets orbit dim red dwarfs, faint suns that bathe their worlds in a deep, slow light. These stars are long-lived, burning steadily for tens of billions of years, offering a quiet stability. Planets in these systems may be tidally locked, with one side always facing the star and the other plunged in perpetual darkness. In imagination, we can drift across the twilight regions, where warm and cold meet, oceans linger, and gentle winds carry life's potential in the slow motion of air and water. Here, time stretches, and the rhythms of climate and life unfold with a profound patience that invites reflection and calm. Other exoplanets orbit suns more massive than our own, bright and intense. Their light harsh, but steady. On these worlds, seasons may be extreme, summer scorching and winters long, yet life, if it exists, has adapted to these conditions with subtle grace. Oceans, clouds, and rivers may follow patterns dictated by the energy of their star, while geology shapes the land over eons. In this quiet imagination, one can sense the harmony between star and planet, the patient rhythms that sustain the system, and the subtle balance that allows possibility to persist. Beyond individual planets, entire planetary systems present a complex dance. Gas giants may shepherd smaller rocky worlds, preventing chaotic motion and stabilizing orbits. Asteroid belts drift quietly, remnants of formation processes long past, and comets swing through systems, carrying ice, dust, and organic molecules across vast distances. Every object, no matter how small, is part of a slow, interconnected network, moving in harmony with gravity and the invisible threads that bind a system together. Some exoplanets are water worlds, their surfaces entirely covered by oceans stretching for thousands of miles. Waves rise and fall with the pull of distant moons, while deep beneath, currents circulate heat and nutrients, sustaining life in hidden depths. On other planets, icy shells cover subterranean oceans, warmed by tidal forces and geological activity. In these remote and quiet places, life may persist unseen, evolving slowly, following rhythms dictated by the patient motion of matter and energy. Rogue planets wandering between stars may also host hidden oceans beneath frozen crusts, warmed by internal heat, entirely cut off from sunlight. These worlds drift silently through interstellar space, untethered, yet alive with subtle motion, a testament to the quiet persistence of matter in the cosmos. Each exoplanet, whether warm, frozen, or hidden in shadow, carries its own story of time, gravity, and potential life, unfolding patiently over billions of years. As we drift among these exoplanets, it becomes easier to sense the intimate connection between worlds and stars, planets and moons, matter and energy. The motions are slow but deliberate, precise yet subtle. Gravity, radiation, and the slow dance of orbital mechanics weave a network of stability and motion, connecting distant worlds and maintaining the harmony of systems across light years. In this gentle exploration, the mind can absorb the patient rhythm of creation, the possibilities for life, and the quiet beauty of worlds beyond our own. And so, as we float in imagination among these habitable worlds, the mind can linger on oceans, clouds, mountains, and ice. One can sense the slow passage of time, the patient unfolding of climates and ecosystems, and the gentle interplay between planets and their stars. The universe is vast, quiet, and deliberate, and in drifting among these exoplanets, we glimpse the profound patience and beauty of creation, unfolding across unimaginable scales. As we drift further into the vast reaches of distant star systems, the diversity of exoplanets becomes astonishing. Some worlds are gas giants orbiting perilously close to their suns, blistering under intense radiation, their atmospheres roiling with storms that could engulf continents in minutes. Known as hot Jupiters, these planets remind us that not all orbits are gentle or worlds hospitable. Yet even in their fury, there is a rhythm, a predictable pattern dictated by the pull of gravity and the flow of heat from their stars. Other exoplanets follow elongated, elliptical paths, swinging close to their suns in long, bright summers, then retreating into icy winters that stretch for decades. The slow transition between extremes shapes every aspect of these worlds, from winds and tides to the movement of clouds and the potential behavior of life. One can imagine standing on a rocky surface as the light gradually grows intense, warming oceans and mountains, then slowly receding, leaving a world wrapped in frozen silence. Time stretches differently here, patient and deliberate, a reminder of the cosmic scales on which all motion unfolds. Some exoplanets may be tidally locked, with one hemisphere perpetually facing their sun and the other in endless night. The twilight regions between light and dark could harbor oceans that never freeze, clouds drifting lazily, and perhaps life evolving in conditions entirely alien to our own. The slow rotation and extreme temperature gradients create climates unlike any on Earth, yet the patient rhythms of wind, water, and orbital mechanics maintain a delicate balance. Here, we can drift across oceans in imagination, feeling the pull of light and shadow, sensing the quiet patience of planetary motion. Moons orbiting these exoplanets offer yet more mysteries. Some may be icy, reflecting faint sunlight, with hidden oceans beneath frozen crusts. Others may be volcanic, their surfaces constantly reshaped by internal heat, releasing gases and dust into the thin atmosphere. Each moon participates in the slow dance of its planetary system, influencing tides, stabilizing orbits, and contributing subtle energy to the rhythms of the world it accompanies. Even these tiny companions play a role in the patient, deliberate unfolding of motion across space. Some exoplanets may be encased in thick, dense atmospheres, trapping heat and moisture in ways that produce endless storms or gentle, persistent rains. Clouds may swirl across the surface, masking mountains, oceans, or hidden valleys. Light from distant suns penetrates these layers slowly, refracted and scattered, creating skies of soft hues and shifting shadows. The rhythms of weather, ocean currents, and geological activity unfold over centuries, allowing life, if it exists, to adapt gradually, patiently, and with profound resilience. Other worlds, drifting farther from their suns, are frozen landscapes, illuminated only by distant stars and the faint glow of reflected light from moons or neighboring planets. Ice sheets stretch endlessly, broken occasionally by volcanic activity or meteor impacts. Subsurface oceans may exist beneath the frozen crusts, warmed by tidal forces or radioactive decay. Life, if present, may thrive quietly in these hidden oceans, evolving slowly over eons, untouched by the light or warmth of their distant sun. In these silent, frozen worlds, time feels expanded, motion slowed, and life itself becomes a patient unfolding. The more we explore, the more the interconnections become apparent. Planetary systems are not isolated. They are influenced by passing stars, wandering comets, and the subtle tides of gravity from neighboring systems. Rogue planets may wander into new systems, captured by a star's pull or passing silently through interstellar space. Clouds of gas and dust drift between stars, sometimes condensing to form new worlds, sometimes feeding existing ones. Each object, planet, and particle participates in a calm, deliberate cosmic rhythm, unfolding patiently over millions of years. Some exoplanets may even orbit multiple stars, creating landscapes bathed in shifting patterns of light and shadow. On such worlds, day and night are complex, changing as suns rise and set in different positions. Seasons may follow irregular cycles, and the climates may fluctuate dramatically yet predictably, sculpting landscapes, oceans, and skies in slow, beautiful ways. In imagination, one can drift across continents, observing the subtle play of light, the gentle motion of clouds, and the quiet rhythm of life adapting to these unusual conditions. Among all these worlds, the potential for life remains a quiet, tantalizing mystery. Life may exist in forms utterly alien to our own, shaped by unique chemistry, temperature, gravity, and atmospheric conditions. Microbial organisms may drift in oceans or subterranean caves, slowly evolving over eons. Complex life, if it exists, may inhabit land, air, or water, following patterns dictated by climate, orbital cycles, and planetary rotation. Even without observing it directly, the possibility of life enriches the calm contemplation of these distant planets, offering a sense of intimacy and connection across unimaginable distances. In drifting among exoplanets, the mind absorbs the vast scales of space and time. Planets trace orbits with patient precision. Moons dance in silent circles. Clouds, oceans, and ice shift imperceptibly over millennia. The galaxy, though immense, feels coherent and deliberate. Each system is a miniature universe, connected subtly to its neighbors by gravity, cosmic dust, and the passage of time. In this gentle exploration, the rhythms of exoplanets, their stars, and their potential for life offer a profound sense of calm, perspective, and wonder. And so, as we linger among these distant worlds, imagination can explore endlessly. Oceans, mountains, clouds, and ice unfold slowly. Planetary atmospheres breathe with time, winds carry subtle energy, and tidal forces maintain delicate balance. Even in our mind, we sense the patient motion of planets and moons, the slow cycles of light and shadow, and the gentle possibility of life on worlds beyond our own. In this quiet frontier, the universe becomes companion, vast yet intimate, inviting reflection, wonder, and the soft serenity of cosmic patience. As we drift even farther into the distant reaches of exoplanetary systems, the imagination can wander to worlds stranger and more beautiful than anything we know. Some may be enveloped entirely in thick clouds of reflective gas, hiding oceans, mountains, or continents beneath an eternal mist. Sunlight, refracted through their atmospheres, may bathe the surface in soft, shifting hues of gold, rose, and deep violet. Storms may rage for decades, winds swirling in patterns dictated by planetary rotation and solar energy, yet all moving with a patient, inevitable rhythm. Other worlds may be dominated by vast ice sheets, frozen landscapes stretching to the horizon, with hidden oceans beneath their crusts. Beneath the ice, tidal forces generated by orbiting moons may stir the waters, creating subtle currents and heating pockets of potential life. In these quiet oceans, life might exist entirely out of sight, microbial or more complex, moving in slow, patient cycles dictated by chemistry and heat. Though unseen, the presence of such life imbues the silent, frozen world with an intimate vitality. Some exoplanets may orbit twin or triple suns, their skies changing with every rotation as multiple lights rise and set in shifting patterns. The surface may experience complex cycles of heating and cooling, light and shadow, while oceans, winds, and clouds respond in a slow, deliberate harmony. Life, if present, adapts with patience and ingenuity, evolving in ways we can only imagine. These worlds remind us that the possibilities of planetary evolution and habitability are vast and varied, each one a small miracle of gravity, energy, and time. The most extreme exoplanets challenge our understanding of habitability. Gas giants that orbit close to their stars may have temperatures hot enough to melt rock, their atmospheres roiling with winds reaching thousands of miles per hour. Some worlds may be tidally locked, with one hemisphere scorched in eternal daylight and the other plunged into permanent night. Yet even here, in these extremes, patterns emerge. Atmospheric currents circulate heat. Chemical reactions persist. Particles drift and condense. The universe maintains order, even in seeming chaos, and the slow rhythm of cosmic mechanics continues. Beyond these, rogue planets drift silently through interstellar space, untethered to any sun. Their surfaces may be frozen, yet warmed internally by radioactive decay or residual heat. Beneath icy crusts, oceans may persist, flowing slowly, carrying life that has adapted to complete darkness. These solitary travelers remind us of the patient persistence of matter, of motion that continues over billions of years, of worlds that exist entirely apart from the light of stars, yet alive with subtle activity. In the quiet exploration of these exoplanets, the imagination may linger on the tiniest details. On a rocky planet, we can watch wind shape dunes over centuries. On a frozen moon, slow shifting of ice cracks open access to hidden oceans. On a distant water world, tidal currents move perpetually, unseen creatures drift in hidden depths, and clouds gather and disperse in a slow dance with solar light. Every motion is deliberate, every process extended across vast timescales, teaching patience and the profound subtlety of the cosmos. The search for habitability extends to chemical signatures in distant atmospheres. Imagining the faint traces of oxygen, methane, or water vapor drifting through alien skies invites reflection on the quiet processes that sustain life. Even in imagination, the potential for life across exoplanets feels intimate, a connection that stretches across light years yet feels deeply personal. The universe becomes a companion in its vastness, offering subtle wonder without urgency, a rhythm so slow and deliberate that the mind can rest within it. Some exoplanets may be in binary systems, where two suns rise and set in complex patterns. Here, tides, climates, and winds follow rhythms unlike any on Earth. Planets may experience periodic heating and cooling, storms that last decades, and hidden oceans shaped by the combined pull of two stars. Life, if present, would adapt to the extremes, evolving quietly, patiently, across the long cycles of light and shadow. In this, there is a beauty that is both alien and familiar, a testament to the resilience and adaptability of matter and life alike. As we drift through the imagined landscapes of exoplanets, it becomes apparent that the galaxy is teeming with variety, possibility, and quiet motion. Every planet, moon, and wandering object participates in a slow, deliberate rhythm, shaped by gravity, stellar radiation, and the passage of time. Even in solitude, these worlds carry history and potential. Every orbit, every current, every seasonal change is part of a cosmic choreography unfolding patiently over millions of years. And so, as we linger in imagination among these exoplanets and habitable worlds, the mind finds calm in the patience of cosmic order. Oceans ripple, clouds drift, storms rage in calm, and life, whether visible or hidden, moves in quiet cycles. Each world, whether scorching, frozen, or gently temperate, participates in the symphony of motion and energy that connects stars, planets, and interstellar space. In this, there is profound serenity. The universe is immense, varied, and timeless, yet intimately coherent, offering gentle wonder, slow exploration, and the soft comfort of cosmic patience. Beyond the familiar planets of our solar system, past the Kuiper Belt and the scattered disk of icy bodies, lies a vast, almost unimaginable expanse, the Oort Cloud. This distant region is not a ring, not a disk, but a vast, spherical shell surrounding the Sun, stretching from thousands to perhaps 100,000 astronomical units, where the Sun's gravitational pull is faint, but still present. Here, in the quiet darkness of interstellar space, billions of icy objects drift slowly, remnants of the early formation of the solar system, each one a frozen testament to time, patience, and cosmic motion. Imagine drifting among these distant objects. They are tiny, fragile, and cold, silently orbiting the Sun in elongated paths that take millennia to complete a single revolution. Some may be just a few kilometers across, others hundreds, and each carries with it the frozen history of the solar system's birth. Their surfaces are coated in ice, dust, and complex molecules, preserved in the deep freeze, untouched by the warmth of the inner solar system for billions of years. In the imagination, one can glide past them, observing their slow rotations, the faint glints of sunlight reflecting off their frozen surfaces, and the subtle motion of gravity shaping their paths. The Oort Cloud is not a place we can easily see. Its objects are faint, distant, and sparsely scattered. Yet the mind can drift there, imagining the gentle, patient motion of trillions of icy bodies, orbiting in a slow, deliberate ballet around the Sun. Some are nudged slightly by passing stars or by tidal forces from the Milky Way itself, their orbits altered imperceptibly over millennia. Occasionally, one is sent inward, becoming a long-period comet that journeys toward the inner solar system, carrying with it ice, dust, and the silent story of the Sun's distant domain. These comets are among the most mysterious and poetic travelers of the cosmos. Born in the frozen reaches of the Oort Cloud, they begin their journey silently, often taking thousands or millions of years to reach the warmth of the Sun. Along the way, they traverse the vast emptiness of space, passing by distant stars, wandering through the interstellar medium, and experiencing gravity's subtle influence. Their motion is slow and deliberate, patient and precise, a quiet reminder of the scale and rhythm of the cosmos. As a comet approaches the inner solar system, the ice begins to sublimate, turning from solid to gas, releasing dust, and forming the glowing coma and elongated tail that we can observe from Earth. The tail always points away from the Sun, sculpted by the solar wind, a delicate, flowing expression of the Sun's influence at incredible distances. The coma and tail can stretch millions of kilometers, drifting gently in space, a visual poem of motion and energy that connects the frozen outskirts to the warmth of the inner planets. The journey of a long-period comet is slow, majestic, and profoundly patient. Centuries or millennia of travel culminate in a brief, luminous approach to the Sun, where solar radiation warms its surface and materials are released into space. Then, after its close passage, it retreats again to the distant darkness of the outer solar system, perhaps never to return in human lifetimes. This slow dance, stretching across eons, is a quiet testament to the enduring order and motion of the cosmos. The Oort Cloud itself is a place of solitude. Stars drift past every few million years, their gravity nudging objects, occasionally sending them inward as comets or out into interstellar space as rogue bodies. Even in these quiet interactions, the motions are deliberate and patient, unfolding over time spans that exceed human comprehension. The cloud is a frozen archive, a memory of the solar system's formation, a vast repository of ice, rock, and dust, silently orbiting the Sun in a sphere that embraces the entire system. In imagination, one can float among the distant bodies, observing the faint light of the Sun reflecting off ice, feeling the slow pull of gravity, and sensing the patient rhythm of their motion. Some objects may drift in clusters, influenced by subtle perturbations. Others travel alone, tracing long, elliptical orbits that carry them from one extreme of the solar system to another over thousands of years. The scale is vast, the distances immense, Yet every motion is part of a coherent system, a silent symphony of gravity, mass, and time. The comets born in the Oort Cloud are more than icy travelers. They are carriers of chemistry, of the raw materials that may seed life or deliver water to planets. Each journey inward is an opportunity to connect the outermost reaches to the inner worlds, to carry ice, dust, and organic molecules across the solar system in patient motion. In imagination, one can follow a comet from the farthest reaches of the Oort Cloud, past Neptune, past the Kuiper Belt, tracing its luminous tail as it swings close to the sun before retreating into darkness once more. These distant regions remind us of the vast patience of the universe. Planets orbit, comets drift, ice slowly sublimates, and stars pass, all in rhythms that span millennia. There is a profound calm in imagining these motions, a quiet meditation on the scale of time and distance that exists beyond the busy inner solar system. The Oort Cloud is a place where silence dominates, where patience governs, and where the remnants of creation drift in serene, deliberate motion. As we float among these distant icy bodies, the mind can linger on the gentle forces that shape their paths, the faint tug of the sun, the subtle influence of passing stars, the slow drift of interstellar gas, and the occasional perturbation that sets one on a journey inward. Each motion is small in human terms, yet immense in cosmic scale, and together they create the silent, patient rhythm of the outer solar system. And so, in this quiet expanse of ice, dust, and distant suns, we find a place to pause and reflect. The Oort Cloud and its comets are not just objects in space. They are reminders of time, of patience, and of the delicate balance that allows a solar system to exist. Drifting here, imagination can explore slowly, gently, feeling the subtle rhythms, the silent motion, and the calm beauty of the distant fringes of our sun's domain. As we slowly drift back from the distant reaches of the Oort Cloud and the quiet, wandering comets, it's worth taking a moment to feel the vastness we've explored. From the familiar planets of our solar system to the icy fringes where time seems almost to pause, and onward to nearby star systems and distant exoplanets, we've traveled across unimaginable distances, yet always with patience, with calm, and with the gentle rhythm of the cosmos guiding us. Above, suns burn steadily, their planets tracing slow, deliberate orbits, each a miniature universe filled with possibilities. Below, in the deepest shadows of the outer solar system, icy worlds drift silently, carrying stories billions of years old. And beyond all, the endless galaxy stretches into quiet infinity, a place of motion, potential, and subtle wonder that can both humble and soothe. If tonight, in this quiet journey through space, you felt a little closer to the rhythms of the universe, a little more at ease with the immensity of the cosmos, then this gentle drift has done its work. The universe is vast, patient, and serene, and you, in your own small way, are part of that same motion. Thank you for floating along on this journey. And if you'd like to continue exploring the quiet, astonishing beauty of the cosmos with us, a simple like or subscription helps keep this calm corner of space alive. Until next time, let the stars guide your thoughts, and the slow, steady rhythm of the universe carry you gently onward.